Hey now, 8 o'clock, I made it again. How's everyone doing? Let me know. Hold on. Turn the sound down a little bit. So I don't have any headphones on tonight because I wanted to play my music ambiently because we have a guest tonight, which is my dog. We have my dog in here tonight because she had surgery. Well, she had to get a biopsy, unfortunately, to check for cancer. And now she has a cone on. So she's in here and we couldn't leave her at home to kind of mess with her. She already chewed out her stitches. So we had to take her back today to get staples. So she's here with us. So if you hear some weird stuff, it's going to be her bouncing around, trying to walk around the office, trying to figure some stuff out. Yeah, we do have slides. I will add them in the Google Classroom. I added them incorrectly for tonight. I didn't realize that until a few minutes ago. But I'll get you the link in a second. Hey everyone, how's everyone doing? Agrinchpon. Hello. Hey, when I'm Plank. Hey, Zero Theory. Good evening, everybody. So let me know if you can hear me pretty well. If there's any because I'm playing directly out of the speakers and not into my headphones, let me know if there's too much feedback or anything, or if that sounds just fine. But let's go ahead and pull up the syllabus for tonight. Actually, I already had it in here. This is some stuff from the Python course. Tonight, what are we covering? So we learned a little bit of Linux last time. So now we're going to learn a little bit more Linux. And so this is part of the operating systems management section of this. You know what? Did we actually go over? I think we did. I think we went over run.sh. I spelled that really wrong. Well, I spelled it right, but all right. I thought that's what it was. Is it run.sh? It's roadmap. Sorry, roadmap.sh, just to show you guys on the developer roadmap, on the DevOps roadmap, where we're at. So we're following this a bit, and this may have been updated recently, and I'll give you this in case you haven't seen it. Paste it in, and this is what this course was built around, this roadmap. I thought it was a pretty good roadmap when I saw it. There's some adjustments, but for the most part, we're following this path. We're not following it in the same order. We're following an order that I thought was a little bit easier to teach. But yeah, we are on the first two sections. We're following that order. So we're doing operating systems concepts in Linux. And so we've got some more managing servers things down here with Linux Unit. So we're kind of down in here, but we're learning a little bit about this stuff. Not a ton. We're gonna learn about process management tonight and some networking things, some basic networking things you can do in Linux. Not networking itself, but we'll learn how to check some of the stuff, memory and storage, and we talk a little bit about file systems. So we are, we're getting in good here. There's one more Linux course after this, and then you'll have to dive in deeper off of the operating system management stuff, and then we'll dive into more stuff. But that is where we are on this roadmap. If you haven't seen this roadmap, did I paste it in? Yeah, I pasted it in. You can kind of check it out and kind of see the path that we're taking, compare what you see here to the curriculum that we have. And we're covering most of this stuff. It's interesting because I actually think that this roadmap looks less intimidating than some of the other ones, like the backend developer ones. There's a Golang one I saw, but it seems like there's more stuff on the developer ones, which is interesting. More concepts here in the DevOps one that you have to dive into. But yeah, this is a Fearless shirt. This is actually an OG Fearless shirt. So if anyone's watching who joined Fearless probably in the past year or so, you've never seen this. It says I'm Fearless. It's a pretty dope shirt. I got a couple of them actually. I got them when the shirts were free. I joined the company at a time when you could just go to the closet and take a shirt when you needed it, but then we got too big, so they would go out of business if we all took swag like that now. So that's why you gotta get it from the Fearless store. Actually, if anyone wants some Fearless swag, I forgot. We actually have a store. We have fearless.store? Is that two on the money? But this is my hand. But there's also me too, being weird. But if anyone wants to ever buy any Fearless stuff, I think I think every proceed, every time you buy something, it goes to power like an hour of code, like at local schools or something like that. Something in here about that information. I can't remember what the initiative was behind this, but if you ever want to buy any Fearless stuff, I know I promote them a lot. It is who I work for currently, but I probably should be. I'm gonna get my own mastermind swag pretty soon. All right, let's see. What's today? Today is Tuesday. Does that sound right? Yeah, today's Tuesday. Today's Tuesday, so second day of DevOps. Tonight's not going to be on Sunday. The class took us like almost 4 hours. Tonight will not take us 4 hours at all. Mostly because these concepts are kind of just give them to you and let you have them and see it and memorize it because these are all just going to be more tools to use to solve problems. And so we can talk about some of those problems. Maybe we can create some scenarios where we can use these tools to solve them. But I don't know. It's all this stuff is fairly straightforward tonight. The only thing that might be weird is sockets, possibly. I don't know, but cool. There are slides tonight. Let's pull those up now. There are definitely slides. I will get them in the Google Classroom as well. So none of the Google Classroom stuff dropped at 7 because I made a mistake and they're supposed to drop at 7 a.m. tomorrow because of I forgot to change. I messed up when I was putting it in, but I can go back in. I'm going to go back in and change it after this, each of the items, so that they drop immediately right after this class. Let's get everybody the slide link. All right, so bootcamp, DevOps. No, that's introduction to programming. I need to move all the rest of the slides into there. Those are all done. We are on Intro to Linux Part 2. All right, let's get you a share link. Let's get it to, what is it? Get shareable link. I don't know why this process is always so hard to me. Anyone with the link, man, it's actually really weird streaming without my headphones on, just because I can hear my voice loud and clear. No, it's kind of weird. Did I change it to? Oh yeah, anyone with the link can view. Copy link. All right, there you go. Slides on the way. Click on it. Make sure you can get into the slides. As usual, we've got our old faithful here. We've got the lemon LaCroix, keeping us hydrated for the night. And just like last night, we have the lime LaCroix here for backup. Again, not to be mixed. Don't mix them together. It will not taste like Sprite. It's actually pretty nasty. And I'm sure now, I'll give it another chance. I'm 100% sure it's the lime way overpowering the lemon. So maybe you can get it to taste like Sprite, but maybe you have to work out the ratio, and I do not have that ratio worked out yet. So I don't recommend mixing the two if you want a Sprite-like watery beverage. All right, so let's go ahead and get started so that this time doesn't take 3 hours. All right, let's go ahead and present. So what did we learn last time about Linux? We learned that everything in Linux is basically a file or folder or executable, but everything's basically a file following the paradigm of Unix. We learned that Linux was a Unix-like operating system. We dove into user management, so adding users and deleting users. And we dove into groups and creating groups and adding users to groups. And we learned that we can manage permissions, system permissions, file permissions. It's a little bit easier to manage them with groups, but we learned about how you could see permissions, how you could change them, what they meant. We learned about the number schemes, that the permissions you have are read, write, and execute, and that we learned the number values for those. Read is worth 4, write is worth 2, and execute is worth 1. So you can determine how the number needed to set the correct permissions for your user group or the world. What else did we learn? We learned We learned how to install, we learned about virtualization. We learned about the 2 types of virtualization. So type 1 and type 2, type 1 being bare metal virtualization. So where the operating system basically is a hypervisor, type 1 and type 2 hypervisor, sorry, not virtualization. We learned the bare metal hypervisors are basically a hypervisor that's running directly on the machine and kind of acts like the operating system. And we learned that the type 2 hypervisor is the one that we were using, something like VirtualBox, where we have a host operating system like Windows, like Linux, like Mac, and we install a hypervisor on top of it. We install an application like VirtualBox or VMware Player, and you use that to virtualize other operating systems. So we did that. We got Linux installed. We ran through that a little bit. So that was cool, just to kind of help people kind of see how that works. So yeah, we got into a decent. We got it pretty good. Oh, we also learned how to do command line navigation. We dove into the command line. You learned how to navigate. You learned about absolute pathing versus relative pathing, and we learned about how to move forwards and how to, using the CD command, changing the directories. We learned how to create files, empty files with touch, and we learned how to manipulate. We learned how to manipulate text files using nano or vim or redirect operators from standard output. So we kind of got our hands dirty a little bit with the command line. And so we're going to need some of that information tonight. So if you weren't here for Sunday and all that stuff is super confusing to you, definitely go back and check out the last one. It should still be here on Twitch. I do have everything rendered finally. So actually, I thought I rendered out every video, which I did. But because of that issue with my graphics card, it was like once it rendered all the way out, all of the files were corrupt. So I re-rendered everything today using the CPU only. Everything's finished. Everything will be uploaded before I leave because the upload speeds here are pretty fast. So I'll throw them in the queue. So they probably won't be available till the morning because I'll have to add some details to all of them, but they will finally be up. Every time I think I got everything handled, technology throws another thing at me. But I'm actually gonna be switching away from this Radeon 7 graphics card. I'm actually gonna be taking it back because I'm still within my 30-day window, and I'm gonna be getting like a RTX 2070 Super, maybe a 2080. And switching back to Adobe Premiere because it likes the CUDA cores. But yeah, I'll be doing that. But cool. Sorry for the distraction. So you're running System 76. How do you like it? J Don Sec. I love this laptop. I am running Pop! OS, but I'm actually running a System 76 laptop. What you're looking at is directly from the laptop, and it's great. I've used Linux for a long time, and getting a laptop that you get it, everything works right out of the box. You don't have any issues with it. You don't have to fight with any drivers. You don't have to fight with Wi-Fi drivers or video card drivers. Really nice, really cool company. It's worked really well for me. I've had it for a little over a year. I bought it in October of 2018, I believe. And it's my daily driver for laptops. Like I have 2 desktops, desktop at home, desktop here in the office, and I have this laptop, and it's my only laptop that I use, and it works super well. I really like it. So our cloud engineer made a diagram of our infrastructure while explaining it to us. I guess it's sort of understandable. Oh, nice. Yes, it is. Let me copy this. If you guys want to see what infrastructure diagrams look like, because you'll get to them one day for sure, check this out. This is what they look like. They all look like this. They all resemble this up front, and you got to do a lot of work to get them good. We're actually going to be doing some infrastructure diagramming when we get to the AWS portion. We're going to use draw.io for it. But yeah, I'll see if I can break that down. I'll definitely try to break that down. When we get to Terraform, you can head over to academy.mastermind.io. Look at the curriculum there. I think it's like, I don't think we get to Terraform until week like 8, week like 7 or 8. But check out on there. All right, let's get back into it. Sorry, I got sidetracked. Let's go back over here. All right, so OS management, Linux part 2, Tux for president, second term. Tux is the penguin. Tux for president, term number 2. So we've done a bunch of things you've seen me do a bunch of things with packages already. You may not have known this is what I was doing, but we've used this before. But packages, what are packages? Packages are simply, it's an application format that allows them to be easily managed. So easily managed, we mean installing them, removing them, updating them. The packages are just packaged up applications so that you can easily manage them, which is really nice. What do we use to manage these packages? We use package managers. So you have packages that you need to manage, so you use a package manager. Yes, DNF is the standard for Red Hat now, even though I do have this on here. This is from last time. Actually, DNF, I actually don't know if DNF is the standard for Red Hat. I know it is for Fedora. I don't know if it is for Red Hat yet. But package managers, there are a lot of package managers. And these are simply applications that you would use to manage your packages. So if you're someone who's using a Mac, think like Brew. Brew is a package manager. Or if you're on Windows, again, Chocolatey is the only package manager I know on Windows. But they just help you install things, delete things, upgrade things easier. So these are just some of the common packages or package managers. There's more on the next slide, so don't sweat it if you don't see one that you care about a lot. But Debian, so I have these on the slide because, again, I think the four main branches of Linux that you need to worry about, because everything kind of spawns off of them for the most part. There's definitely more in here, but the main ones you need to worry about are Debian-based Linux distributions, Red Hat-based Linux distributions, OpenSUSE or SUSE based distributions, and probably Arch Linux-based distributions. And so for Debian-based distributions, apt is Aptitude Package Manager. So it's really funny because everywhere I look says Aptitude, and that's what I've known it as. But I did more research, and apparently now they're like changing the name to Advanced Package Tool, or like some people call it that. Super weird. I don't know which one it is for sure. All I know is apt is the package manager. Apt has always been Aptitude or Advanced Package Tool, because I can show you Aptitude is a secondary tool. Interesting. That's interesting. We're actually going to Google some stuff. I'm going to show you some stuff which made this very confusing. Don't know. I've always used it. Really good program for managing packages. Also, I put under here Debian DPKG. So I think this is like Debian Package Manager or something like that. But apt actually uses DPKG to do a lot of things, but it has more functionality, has additional functionality than DPKG. So you can use DPKG manually if you like. And I'm going to find a package to install to show you how to use DPKG. And I'll show you how to use apt very simply. Then there's Yum. So Yum's a very common one, and it's going to be big. It's big in the enterprise space. So this is for Red Hat based distributions. So things like CentOS, things like Fedora, things like CentOS, Fedora, and Red Hat. And so they have moved, and I put it on the next slide here I have DNF on there. I know Fedora has moved to something called DNF, which I think also references Yum underneath as well, the same way that apt references DPKG underneath. I'm pretty sure, don't quote me on that, but I'm pretty sure. It's kind of hard to stay up to date with all these changes and all these distributions, but Yum is great. Yum is commonly what you're going to be using in enterprise servers. Where you work, you're probably using some type of Red Hat based distribution, and Yum is what you would use to install that. Until I made this slide last time, I had never heard the words Yellow Dog Updater Modified ever. I never even thought about what Yum stood for, but Yellow Dog Updater Modified was probably the very last thing that I would have ever guessed. There's no chance I would have ever guessed that. So that's what you got. You got Yum there. People love Yum. J-Don's like, isn't Snap the way to go now? Snap is the way to go for desktop Linux distributions. Yes, I think Snap is mostly the way to go for desktop installations of Linux. Not so much for work or for anything that you want to have that you're running applications on, running services on, to serve the world. I don't think so. This guy from Philly DevOps meetup. What's up, Anansi? How was it? How was the Philly DevOps meetup? What's the Philly scene like for DevOps? I would love to come up to Philly. It's only like a 2-hour drive from me from Baltimore. I'd love to come through. Yeah, I'm looking at the company wiki. We do have a big infrastructure diagram, but I won't show it because it has actual. Yeah, yep. RPM is pretty common in enterprise as well. Yes, so yes, RPM is very common. RPM is kind of synonymous to well, you kind of use it kind of how you would use DPKG. RPMs are great. RPMs are a great package format to be able to install stuff, and it is pretty common. It's very common. Hey, what's it, Mr. Pentakills? What's up? Absolutely. Let me know if you come through Detroit. I've never been to Detroit. I would happily come through Detroit. I'll happily come through Detroit. So those are some of the main package managers. Let's move on to some other package managers. So package managers continued. I probably should have put package managers and not packages. But Pacman is one. I think Pacman comes by default on OpenSUSE maybe, as well as some Arch distros. If anyone knows any other distros or that's wrong, let me know. Yeah, Arch, I definitely know it comes on some Arch distros, maybe not all of them. YAWART, I forgot what YAWART stands for, but I think YAWART also comes on a lot of Arch distributions as well. I've used it a fair amount. Definitely I'm not an expert with Arch distros or YAWART, and I don't even know if that's how you pronounce it. Don't know what it stands for, but it's another common Linux distro. You'll probably never use these to do work. These are generally ones that are used, like when you're going through tutorials and stuff, you're not really going to see these for anything like enterprise level or work related. You're going to see them for like desktop installs of applications and things. Let's see, you have to add it to OpenSUSE. It has all things SUSE. Yeah, I don't love SUSE. I've used it a little bit, but I don't love it. I don't know anything about Yay at all. So maybe I'll do that. Okay, so YAWART has been deprecated. Let's replace this right now. Let's go ahead again. Let's replace this. Is Yay the thing? Let's see. Yay package manager. Is that a thing? Whoa. Oh yeah. All right. Cool. Oh yeah. So I should have put AUR, like the Arch user repository for packages, but didn't. I'll put that there. DNF, I don't know what DNF stands for either. Let's look this up. DNF package manager. Not important that you know the differences between these at all. You just need to know when you install a distribution, or for when you're working, whatever distribution you guys are using, whatever image your virtual machine or containers based off of, you need to know which package manager to use to install things. So it's just, that's why I want you to be familiar with the different ones. The main ones, again, you're gonna want to be familiar with are apt and DPKG and yum, and someone said RPM, and I guess it sounds like maybe Red had to switch to DNF. I didn't know that it switched to DNF because on all the distros that I used, that I still use, they have not switched over to that yet, or they still provide yum as the main option without throwing out a bunch of helper text for you. Manager updates and removes. Sorry, let's see. DNF or identified yum. Oh, it's next generation of yum. So yes, DNF looks like it's simply a upgrade over yum, kind of like apt is over DPKG. Probably uses yum heavily underneath the hood. Probably. I'm just throwing that out there and what I think. Since we're like, oh, okay, that's why I don't know. It's interesting. It's interesting to talk about when big changes have been made in enterprise applications, like Red Hat. And so whenever someone sees, when you see the word RHEL, RHEL, that's in reference to Red Hat Enterprise Linux. And RHEL 8 is a major. It's a big step. It's a major release, and it usually takes people a long time to adopt major releases. I don't think anything we're using is on RHEL 8 yet. I don't think I also don't think that like Amazon Linux or anything is basing off of Rail 8 as of now either, because they do have a Red Hat based system as well. All right. Let's see here. So those are your packages in Snap. Snap is an interesting one. You can head over to snapcraft.io. And so this is kind of how Snapcraft works is very akin to something we're going to learn later. But Snap basically allows you can install Snap on pretty much any Linux distro, and then you can easily use that to be able to install packages. Install packages on your computer. They're all packaged up really nice. You can just do a little Snap install, which is cool. Or Flatpaks. Flatpaks is one as well. But I think Snap has kind of I think Snap won the war. Even though Flatpak is great, they both think they're the future of application distribution. But again, essentially all these package managers do is package up applications so that you can easily manage them. And that is the concept that I want you to get through for it. And then there's with these package managers, you can use them to manage all the packages that are on your system. So you can use it to both update your mirrors and your repositories, and you can use them to upgrade your packages as well. We're gonna do that in a second as well, and really dive into the differences between them in a second. So let's install some stuff via a package manager. So let's say this is a different it's a separate computer. Close this, that shouldn't break. Let's go down a level, open up our terminal really quick. And I really need to change my default shell. I do not want to be using ZSH. All right. So the way we were in the Linux terminal last time, the way that you initialize or kind of call your package manager is to type in the name of it. So again, I'm using a Debian-based distribution, so I can use apt. You might see me commonly just out of muscle memory typing apt-get. I'm a little bit old school, and you don't need to do that anymore. I actually think apt might be an alias to apt-get, or vice versa, or I think apt has some newer functionality or something. I don't know. But now I try to use apt when I remember. But you might see me type apt-get. They both do mostly the same thing. But you basically use apt. Let's take a look at the man page for apt. So if you wanted to know how to use a tool, if you get into a new system and that's yum and you have no idea what to do, you can go ahead and type apt. And so apt, command line interface. That's not a good, it's just the name. That could probably be a little more descriptive, but provides a high level command line interface for package management system. Yeah, so let's see what, options I have. So here goes update and upgrade. And this is why I wanted to hop into the man page to show you the difference between update and upgrade. So update is used to download package information from all configured sources. So with this package manager, you can configure sources and kind of sources of truth to pull information from about packages. So you can add more, you can remove some. There's a bunch set up by default, but you can add more if you need to get packages from different locations. Other commands operate on this data, perform package upgrades, or search in and display details about all packages available for the installation. So update reaches out for information to these mirrors, to these endpoints, to these sources, and gets information about all the packages and things that you have or have available to you. And then upgrade is used to install all available updates. So you run an update, it gets all the information. So now you know if your packages need to be updated, etc. You have all the information about them. upgrade allows you to actually upgrade the packages using the package manager. And this is all packages that are currently installed in the system. So if you just do apt upgrade or apt-get upgrade, it will upgrade every single package that has an available update. But you can also specify a package. So let's say I want to upgrade Python, and I run an update, make sure I pull some new data. I do an upgrade and I do apt upgrade Python, and it will upgrade just Python for me. So I have to specify. You can do things like full upgrade. So if there's a new release of Linux. So Ubuntu based distributions, Ubuntu and Pop! OS, like the one I'm using, have a twice a year release cycle. They have they release in April. So it's a major version number .04 for the month. So I think right now we're on 19, like the last one would have been 1904. So 2019.04, 04 for the month of April. And then they release in October. So the next one would be 19.10. So the one coming up will be 20.04. It should be released in April. And the one that is released, and then there'll be another one released in October, which will be 20.10. And so that's the cadence that they release on. And then every 4 years, they release a something called a long-term support. And actually 2 years actually now. There are it's 2 years right now. Isn't 16.04 as well? Maybe not. I thought it's either 4 years or 2 years. I don't actually use LTS versions anymore. I just use the latest because I go hard like that. But there will be a long-term support version. So it won't get the latest and greatest. It'll keep packages on it that are stable, and it'll be supported for an extended period of time. So if you need a system that's really stable and well supported, you can grab one of those long-term support versions. I think the last long-term support version was 18.04. So if you ever get on the Debian website or the Ubuntu website, and it's going to ask you, Ubuntu download. It's going to ask you if you want 1804 or 1910 probably. So you see here, 1804 LTS. That means long-term support. And then 1910. Those are two options. So this is the latest. This is the long-term support here. So if you want to do that, if you were ever wondering about that, that's the difference between this. So you can use these package managers to also do full upgrades on the operating system. Well, at least some of them you can. But then you can do things like install packages, reinstall packages in case something got messed up or you need to reset some configuration. Remove or purge. Purge just make sure it removes, but also gets rid of all associated packages and files, etc. So those are the main things you can do. But there's a bunch of other stuff in here. You can search if you're not sure if the package exists or what it's called. You can search. You can sheet information. You can list packages. All this, you can do a bunch of stuff with these package managers. Most of the time, you're just going to be installing and removing, maybe searching and seeing what you have on the system. So let's go ahead and install. Something. So let's do a DevOps tool. So let's download a web server real quick and maybe we'll run it. I actually might already have one on here. Okay, I don't, or at least I don't have the one I'm downloading. So we're gonna do three things. First, we're gonna do an apt-get update. I'm not gonna do an upgrade right now. I'm gonna do an update first. So when you run an update, you can see here I get a could not open lock file, and it lets me know some stuff. Then it says permission denied. What did I tell you last time to think about when you see permission denied? Give some other things here. You can redo those things, but you'll very quickly be able to see these errors and you'll automatically know what to do. And that is just because we need to escalate our privileges. We simply need to, because we're grabbing this information that pertains to our system, we need to escalate our privileges. We need to go into administrator mode. And so we can go ahead and use the sudo command to escalate our privileges. And I typed in my password. You didn't see my password, which is great. When you type in your password, it won't show either. And it goes through, and you can see here, it's hitting these various endpoints. And remember, there's a bunch of them. And it's getting information about the packages that I have and the packages that are available to it. All right. Oh yeah, I could have done sudo bang bang. Yep, you are 100% right. Muscle memory, definitely muscle memory. So I don't know why I typed that. Our system's up to date. If this is your first time installing, if you've never run this might take a little bit longer to run. Usually it's done pretty quick though, but you should get into the habit of doing this every so often. Now, if I wanted to, now would be a good time to do like sudo apt upgrade. So if I wanted to upgrade all the packages on my system, or if I just want to see what it would upgrade, it gives you a printout of all the things that it will upgrade. So I've got a bunch of stuff here that maybe needs upgrading. Some of the stuff was installed but no longer required, so it's going to clean those things up. These are new packages that will be installed, so this stuff will go ahead and get installed. And then these are the packages that will be upgraded, and there's a bunch here, Firefox stuff and LibreOffice, and I could do all this. So 122 packages would be upgraded, 8 would be newly installed, 0 would be removed, and 0 would be upgraded. It tells you how much space it's going to take up, etc. And it gives you the option to have to go and do that or not. I'm not going to do this right now because it may take a long time because it may take a little while because of what's being installed, and we don't need that right now for the stuff that we're about to do at all. What's the point of sudo? Yes, new kernel in here. That's another reason why I don't want to upgrade. There's a new kernel to be installed here. But that's why I don't want to upgrade right now. I'll upgrade a little bit later. But sudo, what's it? Mr. Pentakills. Sudo is a command to escalate your privileges. So allow you to basically go into administrator mode, like on Windows. If you want to run a program as an administrator or something asks you, hey, like as an administrator, do you want to allow this to happen? It allows you to escalate your privileges if you're allowed to, which you should be allowed to if you're the only user on the machine that you set it up. We're going to talk more about like how you manage that with users. There's a will use, there's all kinds of stuff. There's a sudoers file, all that. But all it does is it allows you to basically execute root commands as the root user could do, to be 100% honest. Got to make an alias for that BS. Yeah. For the whole thing, an alias is nice. I don't run it often enough. It takes me 2 seconds to type it out. I don't know. Cool. So let's go ahead. So you saw an update, you saw an upgrade, you saw the output. I could type in yes or no. I just did a Control-C to get out of it. So Control-C, that's something that's good to know too. If something is running inside of Linux, inside of the terminal, and you want to kill that process, or you want to break that process, you can do a Control-C, and that will close out that process. But let's go ahead and install something like nginx. So nginx is a web server, and it's packaged up on pretty much every package manager. So I'm just going to do sudo apt install nginx. And it's going to download some information, and it's going to let me know here again what it's going to do to be able to get this thing installed. It's going to let me know packages it needs to remove, any dependencies it needs to install. And that's a good thing about apt. So I think that's one of the big differences between apt and dpkg. I actually don't think dpkg by default can figure out dependencies that are needed. I don't think, but I'm pretty sure that's one of the main differences. So I'll just click yes, and it'll go ahead and it'll take care of everything for me. So you can see it's doing a lot of different things. It lets me know, my terminal lets me know the progress. Yours may not let you know the progress by default. But now it lets me, it doesn't really tell me anything's installed, but I don't see any errors. So everything looks good. So generally, if the application you installed is a service, generally you have to start the service to see it run. And there's a couple other things you can do with it, but how do you start services? So there's a few ways to start services, and we're going to start up this nginx service. So what you can see first is now I do have the nginx command available to me, so I can start it. But some services start a few different ways, but there are also there are tools on your computer for kicking these things off. So if you're old school and you're used to sysv, init.d, the name of the service, and then the command that you want to check. So maybe I wanted to see the status of nginx, I would do something like this. And luckily this still works. This is a deprecated way of managing processes on a Linux machine. And again, I'm high level showing you this. This is not something you need to be like super focused on right now. I just want to show you that I'm about to start nginx. It looks like it's actually already running. But the new way you would do it, what is it? Is it status nginx? I never get the order right. So now you can use a service command instead, and then you give it service, the name of the service you want to check on, and status. So it looks like it installed nginx, and nginx is now running. Nginx is a web server, and so by default, web servers run over port 80, the default port of the internet of HTTP, of hypertext transfer protocol, is port 80. So that means now that this is running, I can go ahead and try to hit this in the browser, and this will confirm if nginx is started up or not. All right, we got a welcome to nginx page, and this is being served directly from my computer. So just like that, with one simple command, really two or three, I was able to update the information about the packages I could download, and then I told it a package that I wanted to download, and it downloaded it, installed it for me, put everything in the right place, and this one, it actually started it up for me, started it right up, and now this service is now running for me, which is super nice. Super nice. So I'm gonna stop it. I actually don't want this on my computer right now, so I'm gonna do service nginx stop. And because I use sudo to install it, I have to put in my password, and I might have typed that in wrong. And it should be stopped now. So if I run the status command again, it lets me know that it's loaded, but it's inactive. And then let's remove it. So let's use apt to remove it. We can just do sudo apt remove nginx, and it says, hey, this thing's going to be removed. We'll remove it, and I'll try to run service nginx status. Oh, maybe. I wonder if let's see, what happens if I try to start it? Whoa, cancel. Oh, did it not remove because what did I run? Huh. Oh, nginx is not installed, so not removed. Does anyone know what's going on here? I actually don't know what's going on here. Let me see here. Let's get back into bash. I'll figure it out real quick. Oh, did it just leave in oh, I probably should have purged it. It probably just left some stuff behind. So let's try. Huh. I always have good luck with remove. Okay, let's see here. That's still there. I guess it just left. It's very interesting. I'm gonna figure that out in a second. I'm gonna read your comments really quick. I'm very interested to why this is still here. But I'll check that out in a second. Let me catch up on these. I've seen a lot of messages going here. Also, if you hear my dog just moved, and so she's probably about to bark. Two dogs. Let's see here. Wish we had people like you on a channel like this back in 2007 when I first started. Yeah. So One Love IPFS. You do not. Well, yes, it is nice when someone can show you how to kind of use this stuff. But the reason I know Linux is because I had to mess around with drivers and stuff myself, and I learned a lot just from that. Yeah, I get that. I just don't understand why you would ever not run things in admin. That is, yes, Mr. Bender Kills. That's you could absolutely just escalate your privileges permanently to administrator user, and you can do it. Huge security flaw. Also, if you make fat finger mistakes, or if you do something that you're moving too fast and you do something big, there's no guards to kind of stop you from doing anything crazy. And we're human, we're fallible. You can make all kinds of problems with that. Let's see. That was my question. Nginx or Apache? Nginx always Nginx. It's like Apache is good for dynamic things. Nginx is fast. Nginx is a better web server for the current state of technology, better for microservices architectures and things like that. Yeah, nuking partitions, yes. Let's see. Going to Nginx loves the brick. I never have issues with Nginx. It works super well for me. As long as I have Docker or something that helps the OS load. Docker's great. It's removed, but it's still running. I thought I stopped it though. Did I not stop it? Oh no, I stopped it. Let's see. Let's kill service really quick. You're about to learn how to kill services. Ooh, so this is going to be very problematic. I don't know if I flashed this keyboard. I don't know if I flashed this keyboard to have a pipe shortcut key. It's not here by default. Hold on really quick. Let me see. No. If I hit this. Ooh. All right, never mind. I figured it out. False alarm. So I can do PS AWX. What did I do? Grep. Oh, it is still running. I thought I stopped it though. I really thought I stopped it. Oh, is that not the main? Is that not the main? This is very interesting. It's just spawning new processes. But why? This is really interesting. Service, Nginx, stop. Someone tell me why it's not listening. I can kill all. I can definitely kill all. But I want to know why it's not listening. I have no idea why it's not listening, and I want to know why it's not listening. I want someone to tell me why it's not listening. Gotta kill the parent. I'm pretty sure I killed the parent. These are just worker processes. Oh yeah, system CTL instead of service. That makes sense. Kinda. I don't know. People are saying that worked. I don't think it worked. For using SysV instead of systemd. You're right. Well, no, it started up by default. I didn't start it up. It started up by default when I downloaded. Yeah, I did studio app install nginx. I sure did. It has to work. Like, this is crazy. All right. Well, the apt remove or apt purge should remove it. We'll figure out why that's running. That's going to be fun for us to do. You're about to get some context into literally everything that I did with the pipe there and the seeing what processes were running. We're about to get some context into all that. This is super weird. I'll try that in a second when I'm playing. We're gonna get back to that once everyone's kind of on the same page and we can kind of work through it together. And maybe some people can throw out some options that they see that they've learned through here as well. Oh, I didn't even read the whole thing. I just saw you send something. But we could see, maybe I'll sudo root and see if it removes. But yeah, so again, you can install just almost everything you're gonna need. There's probably gonna be a package for. Most likely there's gonna be some type of package if you're using one of the main I guess the main family operating system. Again, if you're using a Debian based or Red Hat based system, there's probably going to be a package for what you're looking for. But what do you do when there's not? So sometimes sometimes there's a package for something that you want to use, but it's not the latest version, or there's a new piece of software and they don't have something packaged up for your system. Now, what do we do when we don't have a package? Like, how do you install software on Linux if it doesn't give you that? You throw out the window. All right. It's good to run these issues on stream because it can teach people. I agree. I used to be super worried about that. I don't care at all now. Like, I like when they pop up because I like you to see me not knowing things, which is super important. Remember, I told you at the beginning, no one knows everything, but it's fun just kind of going through them because these are like weird. They're always like weird problems, and it's a good learning experience. But building applications from source. We're going to build an application from source today. Applications and tools that are built to run on Linux can be installed by manually compiling its source code. Now, we've learned what source code is. Source code being the machine readable code that you or I write. So we can download that source code and we can compile it to run on Linux. And so again, any tool that's been meant to run on Linux can be installed this way by compiling from source. There are different ways that you may have to compile from source, but there's kind of a main workflow that'll work for you in a majority of your cases, and we're going to go through something like that. I was trying to figure out a good application to install from source, but yesterday we saw that if you're on the Python course, you'll see that my Python 3 installation is only Python 3.75, the latest being 3.8.1. So I figured we would install Python since we're going to be using it. It would be valuable. I wouldn't be just installing a random application from source. So let me just make sure I don't already have 3.8 installed. So this is just all of the Python packages that I have installed. So I have Python 2 still installed. And I have Python 3. A bunch of these are probably symlinks to 3.7, but there's nothing in here explicit about 3.8 or anything like that. So I don't think we have Python 3.8 anywhere on the system. Now, I could try to use my package manager to install Python. So what if I did something like apt upgrade Python 3? Let's try this out. We get that permission denied error. Remember, we'll do this again. Sudo dot. And so sudo bang bang will rerun the last command that you ran, but it'll prepend sudo to it, so it'll run it with sudo. And so now we get a bunch of output, and it lets us know there's a bunch of things we can install. Let's go ahead and hit yes. But I don't see anything in here. Did I tell Python 3? Yeah, it should just do Python 3. We'll see. Looks like it's gonna do everything else. I thought it was just gonna do Python 3, but I'm actually gonna let that run. I'm gonna see what's gonna happen. This is a big file. I'm not gonna let it happen. So I'm gonna kill it with a Control C really quick. I might have just broken everything. Control C. All right. So what we're gonna do is we're gonna download. We can probably install it. I don't think 3.8 is available via the package manager. I'm pretty confident it's not, but maybe it is. But we're gonna go ahead and install it from source because that is what we're trying to do right now. So installing a package from source. This can be very scary the first couple times you do it, like very scary. But it doesn't have to be that scary. I think it's scary for a few reasons, and I'm gonna show you when we download the package. So Python download, let's go to downloads. And so you can go to Python source code. Perfect. Python. So we're gonna download the Python source code. It's gonna come in this XZ file. So this is the first reason why installing from source is confusing. Because the one, you've got to know how to deal with the file type that's passed to you. So you may be familiar with zip files, but in Linux there are things like tarballs. There are gzip tarballs, there are compressed tarballs. There's all kinds of different tarballs and different ways of packaging up files. So when you get them, they have different file extensions, and you may be confused about what to do. So let's go ahead and put this into documents. Let's put it into, actually, let's install it from, let's download it from the, command line so you can learn some Linuxy things. So we're gonna copy this link address. So if you wanted to install this from the command line, from a server or something, you would need to have the link address. So you can get that from the website by either clicking on this or right clicking on it and selecting get copy link address, and you can paste it somewhere. So this is the link to download this. So we're gonna take that and we're gonna grab it. So I'm gonna move into a new folder to make this a little bit easier. Mastermind streams, mkdir Linux. Ooh, oh wow, that was way wrong. I'm getting better with these keyboard shortcuts, but I don't know. It's a process for sure. All right, so first thing we're gonna do is we're gonna download that file from the command line. We're gonna use the wget tool to do this. There are other tools you can use this to do this, like curl, but wget's a little bit easier. You might have to download wget. I think curl comes by default, so you might have to do like an apt install wget to get it. But then we're gonna go ahead in here and we're gonna do a wget, and then we're gonna paste in the link to the package that we want to grab. And go ahead and hit that enter key. Goes through, it makes the web request that we wanted to make. It goes ahead and makes that get request, and it downloads our file. So let's take a look at the file that was downloaded. How do we see stuff that is in our folder? We can do an ls or an ll. And now my dog's gonna bark because someone honked their horn. And you can probably see her cone moving. Hey girl, it's okay. So now we can see what is in here. So I'm gonna go ahead now. Now we have this tarball. It says tar.xz. So we have this tar file, and the first thing you have to do is to extract this. You have to expand it to get access to all the files. It's kind of like a zip file. And yeah, someone said you could clone it also. Yes, you could clone the stuff from GitHub. We went over a little bit of Git on here. And so that would be a way that you could avoid this piece. But it's kind of easy to just grab the packages and not have to do a Git clone, because some systems, sometimes you have to do this on systems, and it's easier to manage these packages than it is to make sure Git is there and available for you to clone things. So let's first unzip it per se. We'll expand this archive. So we're gonna use the tar command. I definitely take a look at tar. We're not gonna talk about tar that much on here, I don't think. I don't think that's a part of it. But tar is, again, kind of like zip. It's a way of packaging up files and code. But this is an XZ, so we're gonna give it an XVF. So it's gonna extract the data. It's gonna give it to us verbosely, so that we can see exactly what's happening. And what is the F for? I always throw in the F for muscle memory, and just because it's always worked for me. But let's find out. I don't know what it does. So how can we find out what? Oh, that lets me tell it what file to use. Okay, maybe. Oh yeah, okay. XVVF. I think it lets me pass the file over. So maybe I don't need it, but I use it just because I'm used to doing it. So let's go tar dash xvf. And I think all I need for this, maybe I need a Z, but I'm pretty sure this is not gzipped or anything. So, all right, so that works. So that's the first hard part, knowing what flags to pass, knowing if it's a compressed tarball, knowing, if it's a BZ2, there's a lot of weirdness with the way files are packaged up in Linux and knowing how to extract them properly. So that's the first hard part about installing something from source. So I ran it, it uncompressed everything, and extracted Python -3.8.1. And let me, oh yeah, it tells you the file type. So we're gonna go in there. She's crying. It's time for her. My wife just walked up here. It's time for her to get her medicine. Again, because if you weren't on the beginning, my dog's hanging out with us today. She actually had to get she had to get surgery yesterday to get a biopsy done on her leg. So she has a cone on. We got to give her some medicine. So I'm probably gonna let her out of the room in a second to let her get some medicine. But look at all these files that were in that tarball package. So we got the folder. We went in here and we got we had all the files here. Tar XVF, yeah, XVF. The X is for extract, I believe. The V is for verbose, so that lets us know what's happening. Gives us some output. If I didn't put the V there wouldn't have been all of this output. All the stuff that happened here, without the V, you wouldn't get any of this output. So I want to make sure it was doing something. You need the X there for the file to extract the right stuff, and the F is to let me know to let it know which file to do. Yeah, so we have this here. Now, this is a 3-part process, 4-part, well, 5-part. You download it, you extract it. So now you have the files here and they're ready for you to go. If you got it from GitHub, you don't need to do those first 2 pieces, but we have it here. So this one's interesting because it looks like it includes an install script. We're not gonna use that. Installing from source, the common way, which works for a lot of things, is to first configure everything. So it'll come with this configure file here. So the first thing you do is you run a /configure. You might have to run a sudo. But what is this doing? So this is actually, remember we talked about Linux permissions. Take a look at the permissions of this file and it's green. We talked about, for my computer in particular, when it shows green, what does it mean? But you can see here in all 3 of these, we've got read, write, and execute access for me, read and execute access for the group, and read and execute access for the user, for everyone else. This is a file that we want to execute. So it's something that needs to run. And so to be able to run a file, you're going to kick it off. You can call it by name. So I could have given it the entire path to kick it off. So I could have called it from, an absolute path. So I could have said /home, A Brooks, documents, mastermind, blah, 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 and call this file and it would execute it for us. If I could do that, but I'm in this directory, so I can refer to this file to execute it directly from this directory. A single dot, we learned cd ... to go back. A single dot means this location where I am right now. References exactly where I'm at now. And then so /configure references that file and it kicks it off. So we're gonna go ahead and we're gonna run /configure. Now, no acceptable C compiler. That is absolutely something you just might get. And I meant to go over that. I probably already have these installed and that's why it's working, but there are some build essential tools you may have to install before you can properly install things from source. And build essential, I don't know what the package is called, but there's usually more than one that come with it. I don't know why I clicked on that. That was not even close to what I wanted. I could have clicked on those top ones, but usually people's walkthroughs give you more packages than just build essentials. So I'll pass you this. You may have to install this. There's probably other things. There are other tools that it may be good to download. But Build Essentials will give you most of the common necessary tools to be able to install a package from source, and you may have to grab some more. But what this configure file is doing is it is going through and it is checking the dependencies that need to be added, that need to be compiled and built for the rest of this to work. So it'll run through this and it'll check for a bunch of things, check for dependencies and things like that. And then it'll create this make file that we can then use to do the rest of our setup. So try doing that sudo apt install build essentials. I think I already have it. I'm pretty sure I already have this. Maybe I don't. Yeah, I already have everything that's in here. But that should give you, if you're getting that no acceptable C compiler error, that may be something that you have to do. Everyone can see you. Yeah, build essentials is important. Lots of Python scripts have errors without it. That's very, very true. That's all good. everyone knows what's going on. We're taking off the giant cone around my dog's neck. So sorry about the extra, sorry about the extra noises. We'll just talk about some of this stuff for a second in the chat. Not a big deal. Let's see. But yes, that's what configure is doing. And it creates, again, this creating this make file. And if we look in here, there is now this make file here for us to use. And I'm going to show you how you use this make file. So remember what we've done so far. We've downloaded the source code. We know what source code is. We downloaded the source code and we extracted it. So we took this tarball, or sometimes it's a zip file, whatever, and we've extracted it so that we have our files there. We've gone into that folder and we've used the configure file that's in there, the configure executable, to have it check for dependencies and package dependencies and things like that, and create a make file for us that we can now use. Let's see. The good thing about running GNU Linux is you have the true freedom with your hardware in most cases, full access. That's very true, 100% true. Poor pub, yeah, she's happy. She's doing. Stop, girl. First thing she did as soon as the cone came off is lick her wounds. So actually, little side note, she got it done yesterday, but she was good yesterday, and then she proceeded last night to chew through her stitches, which was gross. I wasn't there. Luckily, my wife was there to take care of it for me. But now she got staples. We had to take her back, and she had to get staples today. So that's why she has the cone. She didn't have the cone before, but she has the cone now. But she's doing all right. She's in good energy. How do you open the README file? So the README file is simply a file that is used to usually show how to use the application. It has information about the application. The way you open it from the command line, like if you're on a server or something, is to either cat it. So we learned about how to get things to standard output. So we could cat the README, and it would give us, the information that's in the README. But that might be hard to parse if it's long. So you can do other things. You can see part of it, pieces of it, by doing things like there are commands like more and less, or in head and less. So if we want to do head and tail, I don't know why I said that. Head and tail. So if I wanted to see the first 10 lines of the README, I could do head, and it would give me the first 10 lines. I could pass in a number to get some more of that information. So I could do head dash 40. And it would give me the first 40 lines. So that's a good one. So head, it does the same thing that cat does. Tail does the same thing that cat does, but it does it for a certain amount of lines. Tail, same thing, tail dash 5 will give me the last 5 lines of it as well. Or you can also do less and go through it. So less will put it. I'm not sure what this interface is called, but it's not. It's almost Vim-like. I actually don't know what it is. But it'll allow you to kind of scroll through it as if you were in a text editor, like Vim or something. You just can't edit it. For some reason, people love less. I dislike less a lot. Like, I never look at things in less like this, because again, maybe you do have the functionality. Oh, maybe you do have Vim functionality. I assumed you didn't. Oh, maybe I'll start using it. Oh, so this is Vim, or Vim-like? That's interesting. Can I do but I can't see line numbers. Can I go to line 40? Line 1? Line 10? No, it doesn't let me. 34? Maybe it does. Okay, that's cool. I didn't, man, I need to stop making, I need to stop using something. This is something I did earlier. I threw out less a long time ago. And maybe I need to start giving all the tools that I threw out with a bad rap early on. Maybe I'll have to give them a chance. But I almost never use less to read it. If that's the way you prefer to read it, excellent. You go for it. So less is something you can use to read it. But I generally just Vim it. But I guess less is a little bit simpler. So cool. Oh, more like Vim than not. Yeah. Can G send GG? But okay, all right, that man, all right. Maybe I'll try to add that to my repertoire. Probably not though. I can tell you right now, like when I like something, I think you guys have seen it. When I like something that I've learned that's new and valuable, I will get happy about it. And this, I mean, to me, it still seems like Vimming it. So that's cool. And I'm so comfortable with Vim, I'll probably just continue to Vim it if I need to read it. But cool. So that's how you can check things from the README. Yeah. Clear command has been a neat tool. I've learned clear is great. To get everything off the screen, you can type in clear. You can also press Control L. It will also do clear as well. So you can try that out. Less is just a text editor, I think. Okay, I didn't know that. I thought less was originally I thought less was a weird function that you applied to things from adding stuff accidentally. That's fair. That is very fair. Keeps you safe. But if less is a text editor as well, then maybe it's not keeping you from adding stuff. You just don't know how to add stuff in less, but who knows? All right, so back to installing a package from source. Again, download the package, extract it, go in, run the configure file, and that will go through and handle all the dependencies and stuff for you. Create this make file. So configure first, /configure first. Next thing you want to run is make. Make will go through and make will start compiling all the things that need to be recompiled, all the things that the configure process identified as things that needed to be fixed and compiled to make this thing work. Make goes through and does that. It does some other stuff, but it kind of gets everything set up for you. Gets everything compiled. This part might take a little while. Depending on your computer, how big the application is, how fast your computer is as well, plays into this as well. So you're now essentially compiling code. You're using your C compiler to compile code. You can see GCC commands here. That's your C compiler, and it's going through and it's compiling these packages, dependencies, etc., for you to use. I drank too much TV static at one time. That was a big sip. That one hurt. I'm not really a soda drinker. So when I take big sips, I was really thirsty right there. And I probably should have had regular water because that hurt. I didn't like that at all. Not even a little bit. It tasted good, but it did not feel good. Geek University, less text viewer. Let's see. Let's program displays the content of a file on the screen. One screen at a time. That is nice because then you can use page up and page down, but I do that in Vim. Can navigate the file, move to specific line, all Vim things. Cool. It sounds like Vim it's a pared down Vim without all the options. Safer Vim. What I will do, I probably won't start using it, but I will start recommending that is a way to look at files because it seems pretty good. Cool. Stuff you install from source won't be updated with package manager. Correct. Correct. No, not that I know of. I've never. Is there a way to update it without needing to be rebuilt? I'm not sure. I don't think so. Not that I know of. Every time I've needed to update a package built from source, I had to rebuild it. So yes, I don't know. And you can see here, this is still running. I've seen source builds take a very long time. And what do you mean by rebuild? So again, think back to when we were learning Go. And we talked about, writing the source code and then compiling it into an executable package. This is very similar. It's like the same thing that you're doing now. That concept is the same thing that you're doing now. So if we need to update, we need to pull the new code. We need to then recompile that code to run on our computer, like we're doing now. So rebuilding is recompiling as we're doing right now. So you need to do the configure again. You need to do this make command, and then we're going to run one more command after this to get things installed via source. And so getting things installed via source. I mean, I know places that won't use package managers for a number of reasons, because You can run into things like, let's say you have a build pipeline. We're doing DevOps. You have a build pipeline and you have a very, very important application and you need to push some updates. And the build, when the build pipeline runs, goes ahead and it pulls up these packages to make your images, and the mirror is down, or the endpoint that it pulls this from is down. That can be super problematic, stop you from pushing new code. There's other ways to solve that by, keeping those packages locally or caching them somewhere, putting them somewhere so that you can use them during those times or use it from there. There's a lot of ways to do it, but I know places that only build their packages from source. Not all the packages, but their main application packages they need to run, rather than using package managers. Also because then you're not beholden. If you do it that way, you don't have to always be beholden to waiting for someone to update the package for you. If some new version comes out, sometimes you have to wait because there's not a release for your architecture or your version. Like, I know that's a huge thing. Like for Linux, like if you go from 1904, so let's say you have 19.10 right now. When 2004 comes out and you're trying to install some packages, it's going to get confused on some packages, and it's not going to see the right release version available for it, and it's going to be like, oh, there's no release candidate for this. I can't install this application even though it'll work fine. It's like super weird, really annoying. But yeah, package managers do get around having to rebuild it. You definitely a hassle. That's why package managers are cool, for sure. So we did a make. You see that took a while. And now to install it, you run a make install. And so this will take the compiled things. Actually, you have to do sudo make install. It'll take all the compiled things and get them, the compiled stuff that it created, the executables that it created, and make install will get them into the places that they need to be. It'll get all of the tools, it'll get all the files, all the things. It'll get them into the location in which they need to be for this thing to work properly. Yeah, and so that's what make install mostly does. That's the high level thing of what make install does. Again, I'm trying to explain these things in a very a pretty simple way, because I want you to understand kind of what's happening during this piece. You don't need to know all the itty bitty ins and outs of that piece, but it's just compiling everything, getting everything into the places that it needs to be, so that you can now run your application. So now let's try this. Let's go Python -- version. Let's see what it did for us. So Python executable is still version 2. Let's try Python 3. Python 3 is still at 3.75, but if I type in Python and hit tab twice, you can see here now I have Python 3.8. We did not have that before. So Python 3.8 -- version. And now I have Python 3.8.1. So we didn't use a package manager. We took the Python source code, the source code that was written for Python. We took it, we installed it. I mean, we downloaded it, we extracted it, we configured it, we made it, we make installed it. So we did a /configure, a make, and a make install, and we were able to do that. So maybe history. We did a bunch of stuff in between there, but this is the general thing. Whoops. I'll type this here. Configure. Make. It won't let me do / because it thinks it's a command. Configure. Make. And then make install. This is the like core way to do this. You're going to run into packages that you can not install this way, that need you to do things a little bit differently sometimes to get around some things. You're going to run into some times when there's additional applications you need for the compile or the make to finish properly, or for the make install to do properly. Man, I cannot spell. It is not make install. It is make install. That's it right there. Zip importer error as well. I get a zip importer. So yes. So zlib not available. So for anyone who got a zlib thing, go ahead and do a sudo. That's why I said there were other packages. I need to find them real quick. Sudo apt Install. Try zlib. Okay, not zlib. Let's see. Let's Google how to install zlib really quick. And so whenever you run into an error like that, can't decompress data, zlib not available, go ahead and search for that. Go ahead and go to Google, search for that exact error. This is how you troubleshoot Linux problems. You take your error and you install it. And look at this. It'll give you a bunch of stuff. I pick one that's relatively new. So let's try the top one. Here we go. Zlib, all right, zlib developer. Ooh, what is that? So there's some options here. So let's go ahead and take this. Zlib C. Okay, Zlib C will do it. But you can just Google around and figure out how to install that package. So even in that error that you have, Sum3A, it lets you know that the package it needs, zlib, is not available. Can't decompress data. This package that I need is not available. And you can either Google that exact error, or you can Google, hey, like, how do I install zlib on Ubuntu? Like, this is how engineers find the answers to their questions. So don't be afraid to do that. So you get a zip importer error. So maybe just type that zip importer error in, or copy and paste that in, and you might get some options. And there are some, I need to pin some of the threads. There are threads that have all of the major build, like, yes, the build tools, essential build tools thing that I gave to you are the essential build tools, but they're not the most common build tools that people use. So you're definitely missing some tools. And I've run it. You know what? It's funny because I actually don't think I even ran it that long ago. Maybe I can find a history of it. I don't know. Maybe I'll find it for you guys. But it's also, I think, a good workflow and a good practice for you to kind of continue down this line and see if you can just Google the errors and see if you can get enough packages installed so that your make installs actually work. So that's installing something from source. So we installed it from the package manager and we installed it from source. Now, that is how you deal with installing packages. Let's get into some of the real operating system management and using tools to know what's going on, using tools to gather information and to be able to get to get information, to have some observability into your system and to be able to make decisions accordingly. In there, using app saying something is missing, you can just do an apt install -f. That's true. Why has no one made a dependencies auto installer? There are dependencies auto installer, but remember, you're installing from source. But that could have also been, you could also, the dependency auto installer for package managers is a thing. And someone just brought it up. So I don't know if you were being sarcastic there because you knew about it, or if you were asking that for real. But it looks like you guys answered that for everyone. So packages, download, extract, configure, make, install. So that is installing packages from source. Just so you're clear on that. You can install packages via a package manager if there's one available, but if there's no package available for either your package manager or your version of Linux, you can install it from source. And installing from source is download, extract, configure, make, install. And again, there's variation in there, but that's the common paradigm that's going to work for most of the things you're going to try to do. And if you install, yes, Zero Theory's got it perfect. If you install it from package manager, you don't need to do none of that. You should do something like apt install package name, yum install package name, and it's very, very easy. Cool. Oh, never thought. Yeah. So yes, there are auto dependency installers built into, or like they're not foolproof, but again, that apt install -f after you've already gotten an error about dependencies will install your dependencies. And so there are some features within package managers that allow you to kind of auto install dependencies. Got a few warnings about directory being owned by current users in cache. Not sure if the install went through. Again, if you're also trying to install Python, just see if you type in like Python and just type in Python and hit tab. This will show you every. So I never talked about tab completion. yet. But type in Python and hit tab. That will show you every executable that you have that has the word Python in it. So if you hit tab twice, it'll show you everything. And so if you try to install Python 3.8 and you see Python 3.8 there, you're probably good. You're probably good to go. Oh yeah, tab is great. We're gonna talk about tab completion. Let's talk about tab completion. We're here. Let's talk about tab completion. Whoa, you see Python 8.8? Where do you see that at? 3.8. Yes, perfect. Then you got it installed. If you see Python 3.8, then you got it installed successfully. Go ahead and type in Python 3.8. And if it drops you into the Python interpreter, you're good to go. And hit Control-C to get out of it if you're already in it. But yeah. With the follower filter, but I don't regret following. So whatever. Oh, yeah. I'm glad you followed. Thank you for the follow. I appreciate that. Welcome to the channel. I leave it on followers just because so many people ask so many questions. But yeah. But tab completion. We didn't talk about tab completion. I think it's probably a good time to talk about it. Actually, hit Control-D to get out, not Control-C. I'm sorry about that. Tab completion. Because everything in Linux is files, really, and directories and paths and stuff, and because Linux is case sensitive, that's not the main reason why. We can talk about tab completion for Windows in a second. You can use something called tab completion. So if you're typing something out, and you probably see me start typing and everything goes really fast. So if I wanted a CD like / home A Brooks, you can see I'm not typing this fast. I'm literally typing in H. I'm only typing in /H and hitting tab, A and hitting tab, DOC and hitting tab to get to documents, and then a capital M and hitting tab to get mastermind. So what auto completion does is auto completion will take in what you typed, check the path that you're typing against, and if there's only one available option, it will complete that for you. So what does that mean? So let's say we were in the home A Brooks folder. Let's take a look at what's in here without all the hidden stuff. In here, we've got a couple things. We have desktop, documents, downloads, .files, but case sensitive. So 3 things with a capital D in here. So here's what I'm gonna do. I'm gonna start typing, like, let's say I wanna go into my document. Let's say I wanna go into downloads. I type in CD capital D. And if I hit tab once, nothing will happen. Nothing will happen simply because there are 3 things in here with a capital D. So there isn't only one answer. So it doesn't know what to do. So a single tab won't do anything. The double tab that I gave you will show you, when you hit tab again, it'll show you all the options you have. So it knows that you typed a capital D, so it wants to complete for you, but it can only complete to one of these things because you typed in a capital D. So you have to give it another letter. So if I give it an E and I hit tab, it's gonna complete because the only thing that matches DE is desktop. So if I hit tab, it will auto complete to desktop. But what happens if I give it an O? If I hit an O and hit tab, it will not auto complete because document starts with DO, download starts with DO. Whoa, my Alexa is listening to me and I don't like it. All right, Alexa, leave me alone. All right, sorry, dog. So if I can hit tab again to see what options I have available to me. Now, I know I have one of these. So if I want downloads, I can just DOW, hit tab, and it will autocomplete. So again, it's checking the path that you pass to it, and it's checking your available options. So tab completion, it definitely takes some muscle memory to start using effectively. But once you do, like, tab completion is everything in Linux. Everything in the CLI, like it's literally, it's the best. Yeah, it's the best. So I can just do something like documents and mastermind, and I can hit double tab to just see what's in there. And if I don't know what's in there, I can just hit double tab and I can go into streams, hit double tab again and go into Python. And yeah, so it's an interesting thing to practice. I would look it up. It's pretty cool. If you're on a Mac or you're using ZSH, you will have different functionality, and you'll have very Windows, not very Windows-like functionality, but you will have different functionality. ZSH by default, the Z shell. So if I open up a new tab, if I want to do like CD, like if I was trying to get to like downloads or documents and I hit D, it's gonna give me more than just the capital D things. It also gives me dot files. This is why I dislike ZSH. This is a big reason why I dislike ZSH. Because Linux is case sensitive and I don't want it to give me dot files when I type a capital D at all, which is really annoying. But the thing that is nice is it will cycle through them if you want, but it's dumb. That's what we're sticking with Bash for now because of issues like that, which I think make it very frustrating to use, to be honest. But whatever floats your boat. Yes, ZSH ignores case. It does. I only learned that very recently when I started messing with it. I really dislike that. Windows tab completion is interesting because Windows tab completion will go, I think it also ignores case, but it'll go in order, it'll do this weird thing where it tries to do them in order from the first item. And it's super weird. It does work. Windows, like if you use the CMD in Windows, it does work. If there's a file, it goes down each file. Yeah, it's weird. I don't like it. I don't love it. But you can get used to anything. I'm sure if I use Windows more for development, if I use Windows development, if I did more Windows development, it probably would make sense. But yes, I can do documents. I'm gonna do documents and then hit tab. And that shows you everything that's in my documents. All the folders and files that are in my documents, deflare. All right. Cool. All right, so that's tab completion before we get into all the Linux management stuff. Yeah, all right. Process management. So remember, we're differentiating again between the command line interface, the CLI. If you ever see CLI, that's the command line interface, versus the GUI, that's the graphical user interface. What you're looking at me running right now is the graphical user interface, and the it's actually weird. Whoa, I made that too large. What's actually interesting is that let's go back. This is the CLI, the command line interface. This is actually a graphical representation of it, but it is the command line interface. Again, if you log into a system or log into a server that is command line only, no graphical user interface, it will drop you into a terminal without all these cool colors. Some of them you can get some cool colors, but without all the cool colors by default. And this is how you have to manage the entirety of the computer. So if that's the case, how do you find out like what's going on the computer? Like, how do you know what applications are running? How do you restart things? How do you find out information? So that's what we're going to go over right now. Process management, what is running? How would you figure out what processes are running on your computer right now? Imagine Firefox or Chrome in particular was crushing your computer, and you wanted to go look and see how much stuff it was taking up on your computer. Like on a desktop, I could go to something like System Monitor. Mac has something called Activity Monitor. On Windows, you can right click the taskbar at the bottom and go to Task Manager, I believe it's called. And this will give you information about, CPU usage and memory and network, right up front, so you can kind of see that stuff. And there's usually a processes tab that shows you, what processes are running. And there's always a ton of processes that you have no idea what the heck they are. But it shows you that and shows you how much they're taking, space they're taking up, how many resources they're using, things like file systems. All this information's here. But what happens when you don't have this? What happens when you do not have this available to you because there's no graphical user interface? You can use things like PS to see what process is running. So let's do a man PS. Remember, man is short for manual. This is how we can find out stuff. So report a snapshot of current processes. This will show you a snapshot of what is currently running. And there are a bunch of flags you can pass to it. I would start to remember a few that work well for you once we do it, but let's just run a PS. Whoa, that's not the right command. PS. All right, it kicks out. Oh, okay, that's fine. I didn't do all. Okay, so PS just shows some things that are running in this session right now. So it shows some things that are running. But what happens if I run a ps-a so I can see everything? Oh, what? Hold on. This is confusing me, actually. PSAU. Huh. Usually, am I tripping? I haven't had to check process in a long time, but does PS not show you everything? PS all work for you? I thought PS all was the default PS command. That's interesting. I need someone. Is anybody on here an OG Linux user? Did something change? It's fine. I'm just wondering. I was expecting for a regular PS to show me a lot more than it did. Just running in the workspace. Has that always been true? Interesting. Terminal process is not my browser GUI stuff. Interesting. Okay, no big deal. That's very interesting. I never just run basic PS ever. I always add flags to it to find out the information that I need. So just interesting, just interesting. So again, PS it'll just show you the processes that are running. It does look like this shows you a snapshot of what's running in the current workspace. Yeah, AUX is what I ran to get the long output of what I just did before. AUX just gives you like everything. The same thing that you kind of see. This is like very similar to what you see in the activity monitor window. And it gives you, let's look at the information that's here. So let's just do a basic PS and let's break down some of that information really quick. So PS, we get a PID over here. You can see these are the titles of the columns. So we get a PID, a TTY, a time, and a command. So PID is a process ID. Every process in Linux gets an ID. You can use this ID to control it, to kill it, to do some other things with it, to find out information about it. So this process ID is important. It is tied to this process. The TTY stands for, I think, teletype, I believe. This is the input device that it's using. It's the input device that's using, again, like your keyboard. You need TTY to be able to do that. Time is how long it's been running, I thought. It's how long it's been running, but this is weird. And command is just the command that's actually has been executed and is running. So we can see PS is the one that we just ran. That's why it's popping in there. ZSH is the shell that we get by default, and bash is the shell that I switched into. So that's interesting. My PS shows more, and PS-AUX is so there needs to be a space between the PS and the -AUX. It should work the same on every flavor of Linux. It may work differently on a Mac. Oh yeah, you said PS with a space. What is process ID, job ID? Yeah, this process ID is just an ID that identifies this process that is currently running. You can use it again to do a bunch of things. And so we get a little more output with something like this. We're not gonna worry about everything that is in here, but an output like this gives you a little more information about like when it was started, the time it's been running, the PID. So you can see here, this is in PID order, process ID order. So this is the first thing, and it goes all the way up to the things that I'm running right now. The command that was run to be able to use these things is right here. So this is like something you've seen, like /sbin/init. But capital A is the same thing. PS-A. Yeah, so that's a shorter output. It's not a wide output as the W entails in the command that I ran. It doesn't give you quite as much information. I prefer this wider output because it gives me a little more information that I can use. But yes, PS is great. PS is used again simply to see what processes are running, and there are things you can do to kind of chain things together to find out information. So if I was trying to find out, how many Chrome processes are running, because we know Chrome's running, I could what's the key shortcut again? I could pipe. So we didn't talk about pipe yet. We're gonna get to pipe pretty soon. Next time, actually, we're gonna get to pipe. But pipe allows you to it allows you to essentially chain commands together. There are other ways to chain commands together, but it allows you to take the output from what's on the left and pipe it into what's on the right. So you take the output that's on the left and push it into the command that we're going to create on the right. So I can do something like this, and grep is a string. We talked about grep already. It's a string. It's a pattern matching service or application, matches patterns. So we're going to look for the pattern Chrome in the output of ps-a. So we're not going to see all the output of ps-a. It's going to output everything, but it's not going to give it to us. It's going to send that information over into basically to run this command against it. And so it's going to give us only the things that have Chrome in there. So this is how you could start to use the PS command to kind of just see, like, this server is running poorly. I know that the web server on here spawns a lot of processes. Let me check how many processes nginx is running or Apache is running. And we can see we have some nginx stuff here. So you can do kind of the same thing. Just change the word to something like nginx. But this is how you can start chaining together Linux tools to be able to help give you more information so that you can make decisions. Is there a way to keep headers when scrolling? Not that I know of. I'm sure there's I'm confident there's a way to do it. I'm confident that there's a way to do it. I only because I think I've seen someone do it before, but not that I know of offhand. It's easier to just get to know unless someone knows offhand, it's kind of easier just to remember what the headers are. But you can also just kind of look, once you see it enough times, you won't need to see the headers to know what you're looking at. So that's process. PS, you're gonna use PS a lot. The next one is PS3. I don't think PS3 comes installed by default on every Linux operating system. But PS3 just shows you relational output of the processes that are running, what kicked them off, what they're related to. And it's interesting. You probably won't use PS3 too often early on. It is valuable. It is valuable in troubleshooting later. I don't think it's very valuable in troubleshooting when you're learning at all, to be 100% honest. But if you're someone who's visual, it might help you. But it just gives you kind of a breakdown of, again, what kicked off what services, what's managing what services, kind of what spawned off of what services. So PS3 is a great way to kind of gather that information as well. So add that one in, maybe put a little star by it. PS and learning how to use PS properly is the real concept that I want you to know. And then the big one, Top is a very important tool for getting information in Linux. It's kind of an aggregator of information. And actually, let me see. Does Top stand for anything? Why is it called Top? I have no idea. Display Linux processes. Top program provides a dynamic real-time view of the current running system. So Top is a real-time a representation of what's running on the system, as opposed to PS, which is a snapshot. Snapshot meaning when you run the PS command, it gives you that output. That is what was running when you ran that command. A few seconds later, that list could be different. So Top is a good thing to do. You can also see processes within Top. So Top has a bunch of information here, and it takes some time to learn how to parse the information that is in Top. It is okay to be overwhelmed by what you're seeing here. Don't sweat that if you are. Let's just run through kind of what you're seeing, so that you can start to kind of break things down. So first thing is uptime. So uptime is the amount of time a system has been up and available, or has been up. I don't want to say available, just up. And so yes, whoa. I have been up for 8 days. It looks like, where'd it go? For 8 days. Yeah, this is system time. It's been up for 8 days. Sometimes it'll give it to you in, sometimes it will give it to you in hours, like hours and minutes, and days, like in the output over here. But this version is giving it to me 8 days. I'm actually not sure what this is. I don't remember what this is. One user logged in right now. This will give you the users. I'm not gonna talk about everything that's in here. The main stuff, the amount of users that are logged into the system, load average. So load is a calculation of basically CPU core usage and the amount of utilization happening to your CPU, and there's some other factors in there as well. But this is a good indication, like a quick glance of like how your system is performing. The number that makes sense, the number that the numbers that you need to be worried about do differ depending on the amount of the core count, processor count that you have on your computer, which is really interesting. So it's kind of hard to, like, I can't tell you what is a bad number for your load to get up to, but you do not want high. Like if your computer's running slow and you check this and the load is like this first number will probably be higher than these two. And you can know that something weird is going on. The first one is what is it? Is it 5, 10, 15, or is it, what is it? 1 minute average? I don't know. They're different averages. So this number is going to move way slower than this one, and it's going to move way slower than this one. The first number is an average of just a few minutes. I didn't check. I think it's a 5-minute average. The middle one is like double that, is like 10 minutes or 15 minutes and 30 minutes or something. I don't know. I don't really remember the threes. It's so interesting that this is all I used to do. Like I was a Linux administrator. This is all I used to do, and I don't even remember what this stuff is anymore. But their load averages. It says here their load averages. They're for different time tables. Let's look it up real quick because I'm interested, and I should know this. 1, 5, 10. Perfect. Thank you. So yeah, the 1 minute average, that's why you'll see this one changing pretty often. If I start doing more on my computer, if I start having my computer do more, you'll see this number start to jump up. And then again, this is the 5-minute average and the 10-minute average. So you can use this information. You can use the information from this load average to know, or to have an idea of how long a problem has been occurring. If you know your load is supposed to be around between 1 to 2 on average, and now you see that this one is up to 15. The 1 minute load average is up to 15. And then you see the 5 minute is up to like 13. And this one is up to like 10 or 11. You know, it's been happening for, a few minutes. I mean, you're driving that number up and up and up. But if you see that this load average is 15, but you see that this one is only 3, and you see that this one is still at 1.5, you know that your situation is just occurring. It's occurring now. So that's how you can use those 3 load averages to kind of determine like time and how long something has been causing issues for, or determine, the state of a machine, or make some decisions or have some inferencing about the state of a machine over a certain amount of time. So that's pretty cool. The total number of tasks, you probably won't use that. The amount running, the amount sleeping, amount stopped. Zombie processes suck. They're kind of these weird stopped, undeletable processes that are really annoying to get rid of. Then you get some information about your CPUs. I wouldn't sweat that right now. And then you get some information about your memory. So this is a good place to come, maybe. I think there are better ways to check memory, but if you're looking at everything all at once, this is how you can find out how much memory is being used, how much you have total, how much you have free, how much you have used, your buffer cache, and your real amount that's available, as well as swap information. Swap. So what swap is, people, it's funny because I know that I did not know what swap was when I first started, and I always forget to like explain what swap is whenever we get to something that talks about swap. But what swap is, you have memory on your computer. It's less important nowadays because, well, it's less important on desktop systems nowadays because our computers have more and more RAM. But what swap is swap takes your memory. So your memory on your computer is actually what's called volatile. It's volatile. So if you cut your computer off, that memory's gone. It's not persistent. It does not. Your memory on your computer does not keep information on there permanently. It stores it for rapid access, for quick access, and sometimes a lot of that information you may not be using right now. So what swap does is it allows the memory to keep the information aboard, which matters the most, that you are accessing. But it takes the data that isn't necessarily super important and it writes it to disk. It writes it to a swap partition. And so it's basically swapping the information from the random access memory, the RAM, your memory, to the disk. The problem is your disk space is much slower than your RAM. RAM is so much faster than your hard drive or your disk space. And so it'll do that. And then if you need to access it, it'll grab it and it'll swap it back and forth. So swap is cool. Swap can be valuable, but nowadays, like for desktop systems, not super important. Definitely needed for systems. Is it the same as the page file in Windows? I don't know much about the page file, but from the little bit I do, I think so. I think it's very similar to page file. I don't know I'm assuming Windows has some type of swap file and maybe that's a page file. I'm not sure. I don't know a ton about Windows, to be honest, except that I can play games on it. But yeah, swaps. It's a cool concept. It can cause issues now and then. It's good to know what swap is. It's good to know what swap is for sure. So you can get that information as well. And what is this in? This is in byte. No, it's in megabytes. Yeah, it's in megabytes. Cool. And then again, now here you have your processes, those same, so real time. So I think it updates every 2 or 3 seconds. But now instead of using PS, you can get the real time view of your files. Of your processes right here. And I think it's a little bit easier to read here. So you get the same things here. You get your process ID that's over here on the left. You get the user that's running it. Then you get your priority. The lower the number, the higher the priority, which is interesting. Then you have your nice level. We'll talk about nice. Isn't super important to know right now, but it's a way to change priority. It's a way to change priority, and the way that the system treats that process. Don't worry about vert. Don't worry about res. Don't worry about this. Don't worry about this. Don't worry about this right now. What you do care about is the CPU. Feel free. The stuff that I'm skipping over, I don't think is important I don't think it'll be valuable for 99% of you learning Linux to know what these things are right now. I think there are things that you can take and learn yourself, and they're concepts I don't think we should cover right now. But you do have CPU right here, so the percentage of CPU that it's using up, so you can see immediately what's using the most CPU. And a lot of times you're going to be using that to determine why something's running slow. This is how I can figure out why my load's so high, as well as memory. And so you can use some keys to kind of shift around. Like right now it's showing in CPU descending order, but you can change it to memory. I think you can do like Shift M, and now it'll do descending memory order instead. So my GNOME shell is using, most of my memory instead. So you can, there are some options to be able to switch the data around and get the data that you would like out of this, and kind of one pane of glass. So this isn't everything, but this is a lot of information here for you to kind of parse through. So check out top. Get comfortable with it. The way you get out of it is to hit Control C. It's a process that it runs, but top is cool. But HTOP is better, to be honest with you. The only reason I don't put HTOP only is because every system you log into won't have HTOP. HTOP has to be installed. If you're allowed to install it, I highly recommend installing it. Why do I highly recommend installing it? Look at it. It's much easier to understand. Much easier to understand. So my computer is running 4 cores, 8 threads. So it sees that as 8 CPU cores, basically, because of hyperthreading. So it's showing all of my cores up here and their utilization. So I talked about your load being a function of your core count and kind of the utilization of your computer. There's a lot of things that are used to calculate that. But this way, I can now see I can see what each individual core is doing. I can see that 6 is spiking right now, and now it's gone, which is super duper interesting. And I can see it in a visual way, which I can understand. Memory, I can see memory right here. I can see that I'm using, okay, this is a little this is probably not true, but I'm using 13.4 gigs out of my 15 gigs. I'll show you why that's not true in a minute, or why it's probably not true in a minute, or not completely true. And then swap space, I can see how much swap space I'm currently using. Here, out of the 4 gigs that I have, I'm using 1.03 gigs of swap space. Then I have my number of tasks here, and I got one running. I can see my load average here, the same load average, the 1.510. My uptime is 8 days, 2 hours, 7 minutes, 2 seconds. And then I get the same kind of output that I have here before, descending CPU order. I can see the command that's running. And again, this may be a lot. It's a lot of information coming at you fast, but what you can see here, even if you don't know what you're seeing, is that, hey, I know that I can see what process is running, and I can see kind of what resources it's using up, which is nice. Or I know that there's a tool that I can use called htop that would allow for this. If this is htop, if you type in htop and it says htop is not found, you should be able to just do like an apt install htop or something. But again, htop's great. I would get comfortable with top, because you may run into systems that don't have htop installed, which is most of them, I think, and you may not be able to install them. You may be able to, but you may not be able to install them. So I would get comfortable with top as well. But on your personal computer, a computer you're messing around with, personal servers and stuff, definitely get htop installed on there. It is a superior program. All right, now processes are running. How do I stop them? Like, let's say Chrome is killing everything, or something's killing everything. So maybe I want to let me start up a different application. Let's start up like the virtual box and like Spotify. All right, so we're in htop, and I'm like, oh man, my computer is running so slow. What's going on? And I see that Spotify, very conveniently, is taking up, okay, now it went down, that was dumb. It was taking up tons of space. Actually, can I, yes. htop is great because I just started typing Spotify, because that's what I wanted to find, and it highlights it for me and it follows it for me, and this is why htop is great. But the process ID is what's important here. We can use this process ID. There are other ways to do this, but we're going to use the kill command here to delete this, to kill this. So in top, you can kick this off by just hitting K. And that did work here. I'm not going to do the rest here because it's confusing what's happening when I do it inside of htop, but you can do it here. But I get the process ID. So Spotify looks like the parent process. The process that's running is 20126. With that information, I can use the kill command to kill it. Or the faster way you can get, another way you can get the process ID is to do, again, that PS command. I like the wide output. Actually, let's get rid of the wide output. And what's my key command for, there we go. And I can grab for Spotify. And I can go to htop. I can see that Spotify is killing my computer. Then I can do PS AUX and grep Spotify, and it gives me some Spotify things here. So I can use the kill command, and I can do kill all, and I could type in this, and it will kill all the processes. Or I could do a kill. So let's just do one. I'm gonna do a kill, and I'm gonna copy this and copy paste it. I'm gonna kill this process ID, this PID. I'm gonna kill it. So I didn't get any crazy output. Let's check what's still running. And now when I run it, you'll still see Spotify things running. This is because the kill command has some modifiers. It has some levels to kill things with. Generally, if you want to get all those processes gone, give it a -9. I forgot what -9 stands for. Oh, that doesn't exist anymore. Let's see. Oh, never mind. The kill command did work. It just took a little while. That's cool. That's nice. It just took a little bit of time to kill everything. So for some processes, again, like nginx, let's take a look at nginx again. Sometimes the kill command will kill a process, but whatever the parent process is, or something else, will spawn a new process, and you won't be able to do that. These signals that you send to it, the -9 is a signal that I sent to it, and it tells it how to kill something. It tells it whether it should go ahead and just savagely destroy the processes, or if it just should savagely destroy all the processes, or it should be graceful and say, all right, process, I know you're going to finish soon, or I know you're going to finish at some point. You know, when you're in a good place for me to kill you, then I'll come kill you. So you can gracefully kill things. You can do a bunch of stuff. There's a bunch of different options here. You can just Google like kill signals. Google like Linux kill signals. Don't just Google kill signal, especially not from a work computer. That's probably an issue. So we can just Google something like Linux kills process kill signals. And you get the ones that you get a bunch of things here that all do something different. Read up on those. You can read up on what different ones you want. Yeah, they all do different things. Read up on those. It'll help you determine which one to do best. But let's see if we can get our nginx process killed now. I wonder if. So it's still running. Why is it running? So we did sudo service nginx. Actually, hold on. That's that. Ignore what I'm doing here. Is it actually running? Yeah, it's running. Hold on. Whoops. Oh no. Hyper. Let me go back up. Let me go to localhost. Just doing a little bit of troubleshooting just to make sure. All right, stuff is still running. Okay, let's do it. Let's see. Let's clear this, and we're gonna do a PS, a UX, and we are going to grep nginx. Still running. Let's go ahead and try to run our kill command. We're gonna give it a -9 again, and let's do this one. And so these are worker processes, not permitted. Let's go ahead and do escalate our privileges. And is it still running? Kill. TANF is better. I'll check it out. I'll see what all those are for. nginx is still, in fact, running. Different PID. So we killed the worker process. So we must not be getting the parent process. But whoops. R. What? All right, let me see the one that you said is better. I just want to see the output difference. What did you say? TANF. Oh, that is better. Well, that's better for what we're doing right now. But it shows no process for it. All right. Okay. Hold on. So let's try sudo service nginx status. All right. It says it's starting. It's running. It's loaded, but it's inactive. It lets us know where it's loaded. So there's a service here, enabled. Start, stop daemon, quiet. All right, exec stop. Start, stop daemon. And so maybe it's our PID. Let me see. Shows process ID listening on the port. Went from 7 to 6 though. Oh yeah. So it definitely deleted. It definitely deleted one. You know what? I have to see if I actually sudo root. It'll delete it. Service nginx stop. grep nginx. So oh man, kill all nginx. Oh, okay. All right. So kill all nginx worked, but it did not work the first time we ran it with my user, but it did work as root. So I actually changed to like the root user, which is the full administrator. I can do whatever I want on the system. And I was able to remove it. Let me make sure it didn't start back up. Okay. So that worked. That was interesting. I don't know. I actually have no idea. I have no clue what happened there. Actually, let's look there. Port 80 is not listening anymore. Nice. Okay, that's horrible way to stop nginx. I 100% agree. We did that. We tried service nginx, sudo service nginx stop. We tried it. If you killed the main PID without when that shut down as well, yeah. But it was only showing me PS was only showing me worker nodes. So I'm not sure. I don't know what happened there. Maybe I don't know what happened there, to be 100% honest with you. It was only showing me the worker processes and not the main process. Maybe one of those worker processes was the main process, and I could have just tried to get one of them. But I ran a kill all as my user before, and it did not work. Interesting. All right, all good there. So I think that is all the main stuff for checking your processes. Again, it takes practice to get comfortable checking for processes and seeing what they do. Again, know you have the PS command, the top command or htop command, and the kill command. Oh, sudo my netstat. Sure. Which one? Man, all right, I'm getting there. Grab netstat. I'll do the tannip and the tulpen one. So sudo $2089. Same output. But I was seeing. Oh, so okay, I got you. So that you could see the. Is that why it wasn't showing me the service? That's certainly possible. Gotcha. Then you can see the PID process listing on point. Gotcha. Yes, you're right. Yeah, or I could have done a listing of open files. For sure, LSOF. That's how you check the open files on your computer. Remember that in Linux, everything is a file. Everything is a file or directory. Yeah. So LSOF would have worked as well. All right. There are so many ways to do stuff. Take these, start with these, make PS tree like off to the side. Get a handle on PS. Definitely find some good PS commands. See if you can find some good flags for yourself. The common ones people are using. Top and htop and kill. See if you can kill some files. And that's the basics of process management. Pretty simple. You can make money. You genuinely can make money working somewhere and monitoring servers. And you can make money by learning how to log into them. So you learn how to SSH, learn how to move back and forth, check processes, and check processes, check memory, things like that, and kill processes. You can make money doing exactly that. Which is interesting. It's getting harder and harder to find jobs like that, but you can absolutely make money doing just that. So it seems simple. It can be very valuable. Now, let's check how we check memory and storage. So actually, how much do we have left? Memory and storage and a little bit of network. Easy. We'll be out of here very soon. So memory and storage. How do you check free memory? So we did see that in top and htop that you could get some memory information, but there's some better. So you see top and htop here, but the command I like to do to quickly check memory is free because you have a little bit more control over the output. So the free command kind of looks like the output by default that you get when you see it in top. And actually, it's worse because it's in bytes rather than megabytes. So it's hard to see. Like this, what does this mean? Like I don't know. Like, I have no idea what this means. Or it's harder for your eyes to parse. You know what it means, but it's harder for your eyes to parse. So you can give this some flags. You can say, oh, I want my output in megabytes. So you can do free-m. And now it'll give you to you in megabytes, which is a little easier to read, but may not be what you want, but could be what you want. I like seeing mine in megabytes, to be 100% honest. But you can do G, so you can get it in gigs. So now I have 16 gigs of RAM, but there's some formatting or some things that take some of that up. So 15 gigs, and I'm using 12 and 1 free, and 1 in buffer cache, 1 available. Swap, 3. So I could see it in G, but H is the best way that you're going to commonly do it. H is to make it human readable. You guys threw it in there. And you can see this output is much better than any of these. It gives it to you exactly. It gives you the actual thing that it's doing. I think you can combine them. I think if I want it still human readable, but in megabytes, no, I can't. I thought I could do that. I don't know why I thought I could do that. Yes, I hate it is annoying getting in gigabytes, but now systems have so much memory that I think gigabytes is fine. And I think you only need to go down to megs when you are really suffering some issues and you're is it actually exhausting memory? I don't know. Oh yes, I agree with the G. I definitely agree with that. Which I do wish it would just be G. Not G. I 100% agree. Even with the MI over here, is there some overlap that why would they add an I? Gigabytes, bytes, megabytes. I don't know. Give me bytes. Yeah. Yes. Oh, maybe. Oh. Is it megabytes? It should. We're gonna call it. Can we call it megabytes from now on? Megabytes, the most bytes that anyone's ever bitten. That's what we're calling it. Let's see. So yes, this is how you get the memory. It's very interesting how you would see something like. You see how it has 15 gigs total, 12 U's. So now what would that tell you? That would tell you that there are 3 bytes available to you, but it says there are only 1.2 gigabytes that are free. Then it has the shared buff and cache thing here. Memory that is in your buff cache and your available is what is available. So that is what equals up to mostly 3 as well as the shared. But it's super annoying. The very first, in the beginning, no one explained this to me, and I was so annoyed. And I'm telling people, your server's fine. There are 3 gigs available, and that's true. But buffer and cache is kind of this it's a cache. It's this weird buffer space of memory that it can kind of swap data out for. The data may be consumed, but it can rid that data and use the data that you need, for sure. But an available is the actual amount that you have available to you. And so that's why those things added together will give you the difference between these two. So you can hop down here and see there are 3 gigs available for swap, but up here it's a little more nuanced. And while there are 3, understanding where they are is it makes it a little bit more nuanced, because you may check out this available thing here, which is super annoying, super duper annoying actually. So who's that? Hey, Jumpin' Worm. Welcome to the stream. Thank you for the follow. So that's how you can see some memory stuff. And again, you can see the same stuff through top. So free, actually, I don't think free works on a Mac. If you're on a Mac, I do not think Macs have free, which is interesting. But again, you can see this information from top as well. Just not as it's not formatted as nicely, but maybe there's a flag you can pass in. I don't know. I don't use top to check my memory in that fashion. Or you can just use this sweet memory bar in HTOP, which is kind of nice. It looks like, oh, I forgot about all the extra stuff down here that HTOP gives you to kind of dig deeper. It's pretty nice. No pun intended for the nice minus and nice plus over here. All right. So that was how you check memory. Now, so actually, real quick, and maybe this is something I should have talked about first. My assumptions that if you want to do the DevOps course, that you kind of understand the resources of a computer. Maybe you don't. So let's just cover those super quickly. One, you have your CPU. Your CPU is basically the brain of your computer. It's the central processing unit. This is what does the crunching of data and makes decisions. It crunches data, passes information back. It's where all the ones and zeros get processed. Well, they get processed everywhere. Honestly, whoops! I forgot my dog was here. She scared me. But this is the brain of your computer. The RAM, random access memory, that's the RAM is there. It's volatile memory. That's the thing that we just checked. We just checked volatile memory. So this is not persistent memory. This is not things you save on your hard drive. This is memory that you have available to you for your computer to pass information to, so they can quickly get access to it and process data. It works in conjunction with your CPU as well. And so usually nowadays on computers, you'll have 8 or 16 gigs of RAM. Again, that's a random access memory. Remember, it's volatile. And that is what we checked with this free command. Then we have storage. We have persistent storage. So hard drive space. So how much hard drive space do you have? You have 100 gigs. You have 2 terabytes. Who knows? But these are your HDDs, your hard drives, or your SSDs. This is persistent storage. This is where you save your files to. This is where you save, your images and your movies and all that stuff. You save this there. This is where the file system is. When you install your operating system, it is installed on persistent storage there. So those are kind of the main. The main 3 things that are going to affect performance, as well as network performance. We're going to talk about networking in a little bit, and IOPS and things like that. But these are kind of the main resources that you're usually going to be checking. So we just checked that random access memory. Now we're going to hop in to the file system and the disk space, where you will be saving things persistently. So how do you check your storage? How do you know how much storage space you have left? You have 2 different things. You have a DF, which lets you know file system information, how much stuff's left on your file system, and DU, which gives you information about the amount of space that directories and files take up. So let's see. This might be, if I go to files right here, my file manager, and I click on, like my computer or something. How can I get it from here? How can I get it from, maybe I go to about, I think on Macs, if you go to about this Mac, Windows, I think you can just go to like this PC and see this information. Oh, this is interesting. I actually don't know how to see my hard drives from the GUI. Interesting. I don't know. This feels weird. Maybe I have to go to like disks. That's random. Shouldn't have to do that. But I can see my information from here, but I'm sure there's a way in here to get there. I don't know. No big deal. Yeah, you can use Gparted or something. I know the application, but I assume there was a way. Oh, I clicked other locations. Oh, I had to add computer to a location, I think, and that'll do it. But you can see how much hard drive space you have. So I actually have 500 gigs of SSD space here, but after formatting, it takes it down to 494, and I'm using 275 of that. So the way that you check that information on here is you can do a DF, and so DF will give you file system information. So the Linux file system is an interesting one. And I put a video, a video released Monday about the Linux file system. So watch that video. I think it's a good overview on the Linux file system. But so this is exactly one of the reasons why I don't like Snap. And the way that it installs things on your system and it shows up in here. But when you hop into DF, why do you have so much free space for slash? Where were you looking at? For slash right here. This is my main slash. Remember I told you slash is the root of the file system, and I did not answer the question in Google Classroom. I'll check that out after this because I got to go fix some stuff in the Google Classroom. I have so much space available because this is my main file system. So I only have I I have 58% space left on here, and you don't have a separate home folder. So yes, it is common to separate your home folder, your home partition, your home partition, for a number of reasons. Because I got this laptop from System 76, it didn't come that way by default, and I feel like nowadays there's no need to mess with it. That used to be a very common thing of separating out your home partition from everything else, because then you could your home partition is where all of your, like, most of the system files and stuff will be in one place, but things you downloaded, like your movies and your files and things you work with, will go into the home partition. So people generally did that to kind of keep those things separate, as well as when you needed to do backups and other things. It made it a little bit easier. There. I don't find a lot of value in that any longer. Also, because I don't keep a lot of files on my computer either. So no real need for me to separate it, but you could do that if you want. But take a look at this. It'll show you a bunch of stuff. Slash is going to be the main system partition. And so this is probably going to be the one that you're going to be looking at the most. So we're actually going to pass a flag to this, which is the -H, to make it human readable. You can see now this is not quite as confusing anymore, and it's a little bit smaller. So we can see here for slash, I have 257 gigs available, total of 461 gigs, which is interesting, and 181 gigs have been used, 40% usage. So if you ever have a server that's messing up, if a file system is 100% utilized, like a main file system is 100% utilized, you will see all types of problems. Why? Because everything in Linux is a file. So if something a process needs to be spun up or something, and it needs to create a new PID file for that or something, it can't do that. So it causes all kinds of issues if your file system is full. So this is something you have to check for. It's actually can be very difficult to troubleshoot this because someone just said it. Sometimes your keyboard can stop working, or you can't, you can't input what you need to do to get that information. It's really annoying to run into disk issues. Luckily, with the cloud, I don't run into many disk issues anymore, but you can also check those in other ways. But if you're on other systems, it can be pretty weird. It's a pretty weird problem to solve. Now, I'm not going to explain, just because of the time, I'm not going to explain which each of these different file systems are, or what each of these different partitions or mounts are, just because that video is there for you to do that. But the mounts basically are just different places that information is attached to that you can use to get information. These like dev loops and stuff, like it's all that's covered in the video. I don't want to dive too deep into that, but DF is how you can get information about the file system. Again, slash is likely going to be the thing that you're looking for here. And this is where you can get that information, and you can see, the percent used and things like that. If you want to determine how much space you have left, or you want to determine, this is why I like when you're about to install an application, it lets you know how much disk space is going to take up and asks you if you want to do it. Maybe if you have a computer that's running low on disk space, maybe you might want to check how much space is left because you're getting near the edge and you don't want to install this application because it could take up a bunch of information, or the rest of your information. How do you like your System 76 machine so far? A couple people have asked me that. Love it. I definitely love it. I like it a lot. It works super well for me. I've never had to troubleshoot any drive. It just works. It's the Mac paradigm. Like it really has been the Mac paradigm. As someone who uses Linux and knows Linux, like I've never had an issue. I've never had to troubleshoot any issues with it. It works everywhere. Like I had issues where like where I installed Linux on my own hardware, where I would like go to places that had like open Wi-Fi and I couldn't get on Wi-Fi, even at like Starbucks and stuff. I've never had any issues like that with this machine. Like I haven't had any issues with it at all. It works. It's super fast, but I bought the NVMe SSD. So like it's crazy fast. Only thing I don't like about my particular machine is the battery life isn't great. Battery life is not great. I can probably get 5 hours of unplugged time if I really wanted to, five and a half. And the other thing is the trackpad on this particular laptop is not very good, but I use this Logitech MX Master, which can link to like 3 computers via Bluetooth. So not really a problem for me, but if you're a trackpad user, trackpad on here isn't great. The keyboard's phenomenal on this laptop. Screen's good. It's pretty sturdy. I've like dropped it and stuff, works well. Has a bunch of inputs. Like I have an SD card reader, so if I'm shooting anything, I can just pop everything off. But good laptop. I highly recommend if you want to use Linux and you don't want to fight with your computer and you want good support, I would definitely check them out. I haven't done LVM stuff in a while. Yeah, LVM is Linux virtual machine, and it allows you to do some interesting stuff. Snap and some other things take advantage of some things like that. It's really annoying, really annoying. Say sir, cloud is expensive. I like Deddy servers. Cloud can be expensive, absolutely. Don't let anyone tell you. Everyone tries to say, "Oh, go to the cloud, it's cheap." If you're a larger organization and you can invest in your own systems, I mean, it's definitely not always cheaper at all. It's not cheaper. It's more convenient though. It can be cheaper for a lot of people, but every use case it absolutely is not cheaper. So don't let anyone tell you that. We'll learn more about that in the cloud section for sure. DigitalOcean, Vulture for the win. Absolutely. I love DigitalOcean. Colo a server with 256 gigs of RAM, less for $300 to get it into $4 USD a month. I guess, but you have to buy that server first though. Like you gotta buy it. That's the problem. If you're gonna colo something, you have to buy it. So yes, that would be cheaper if you already had the server. But if you didn't already have it, that's a problem. Bro, if you don't want to see Snap NDF, just use the alias squash. Yes, I could do that. I could absolutely do that. That's a good. I can see you guys like aliases for everything. I think I'm dealing with a lazy bunch. Lazy people make the best DevOps engineers. Automating out all the stuff that bothers you is absolutely what you want to do. I actually never check my disk space on here. This is my personal laptop. I never check my disk space on here, and because I'm never going to use it up, to be 100% honest with you. And you're not going to. Snap's not going to be a thing on any production system that you're going to have. Servers are sold so cheap now. That's true. Web hosting supplier back when when employees spawned off SoftLayer. I know a lot about SoftLayer. 42 full rack co-located. Which OS are you running on it? I'm assuming you're asking about the server, but I'm doing Pop OS. 5 hours? Yeah, 5 hours is so 5 hours is not that bad. 5 hours is not that bad until I had an XPS 15 for a while, and I could legit get like 13 hours out of that thing. Like I'd get like 12 or 13 hours out of it, and so it made me a little bit spoiled. It definitely made me a little bit spoiled. It made me spoiled. That plain and simple. I only really notice it when I take it to conferences, but. I'm probably going to be using an iPad for that now, to be honest. But taking it to conferences can be a problem. I like to take notes inside of Notion for things like that, and conferences aren't always the best places to have your laptop installed. I mean, to have your laptop be charged up. Don't always have good spots for that. But there are other, like System 76 has more laptops than this laptop. They have some that have better battery life than that. They can give you all day battery life. But yeah, I do. If you're also interested in Linux, consider checking out the XPS Developer Edition. Dell makes Ubuntu certified laptops. They're pretty good. I don't like the XPS 13s. They're too small to me, period. The laptop I have is actually a 14-inch screen, and that's enough to make me not want to hate it. 13-inch screens are too small for me to use. Like I can't get with it, to be 100% honest. You will get better battery life. The price premium is a little more. But yeah, definitely check those. You can definitely check those out as well. Oh man, there's a lot of messages. I didn't realize how many. I was slowing this down. I'm gonna skip a bunch. because we need to do the last section really quick. All right, cool. So very simple. And again, there are flags with all these commands, but df is the way that you would check your file system. The way that you would check your file system space so that you could troubleshoot. So again, we're learning how to get information about our system so that we can make decisions accordingly. And the last thing is, last thing we want to do is simply network. So networking is pretty important. This is not going to teach you. Networking or networking concepts. It's going to teach you very basic networking concepps and just some of the tools that you can use to identify network issues. So when identifying issues with a system, it's going to be it's got to be a network issue or a system resource. Usually it's a network issue, a system resource issue, or an application issue. And so far you can use all the tools that I've taught you tonight to determine which one of those things it is. It may not help you solve it. Like if it's an application issue, you don't yet know how to get the information to solve that yet, but we will learn that in the bash portion of the bash scripting portion of this next time. But that is the goal of this, for you to get enough information to figure out where the problem lies. So networking, let's talk about your loop back address. So I'm not sure if any of you understand how the internet works, but the internet works via addresses. It works particularly via something called IP addresses. And IP addresses, I'm 99% sure it stands for Internet Protocol Addresses. What does IP address stand for? Pretty sure it's Internet Protocol Address, but maybe not. Yeah, Internet Protocol Address, perfect, got it. I was like sure it was that, but again, because I was wrong about the IHOP thing, I now second guess everything that I say. So loopback address. So internet works via IP addresses, which are these numbers. IPv4, which is 4 octets, four 3-digit numbers. Possibly not up to 3-digit numbers, 4 up to 3-digit numbers separated by dots. But we're kind of running out of those things. So we now have this thing called IPv6, which is now longer, and it's not only numbers, but the internet works off of those things. So these digital addresses point you to where information lies, just like your home address. That's how mail knows how to get to your house. This is kind of how IP addresses work as well. We're not going to dive into DNS. The DNS is the way that your computer knows that google.com goes to an actual address. So actually, let me show you. We're gonna do ping and all that in a second. But any computer that is on a network, that is on a public-facing network, a network period, but public-facing network in particular, has an IP address, and that's how you can get to it. But if a computer has an IP address, how do you reference? If you use that to reference a node on a network, a computer on a network, a place on a network, how do you refer to your own computer? So let's talk about the loopback address. Loopback address is the address, again, that identifies the computer. It references the computer or the node in which you are on currently. So my laptop's IP address, I can always refer to it with the loopback address. The loopback address is 127.0.0.1. This is important. This is a very important thing. Write this down for sure. So this is the address. There's like nerdy shirts that say there's no place like 127.0.0.1. That's home. That's home. And so we're going to talk about the actual like loopback interface. I'll show it to you and stuff, but essentially this is your loopback address. This is your loopback address here. There is the same way that google.com actually translates into an IP address, a list of numbers. This list of numbers is also generally aliased on your computer to something called localhost. So you saw me type in, when we were running nginx, you saw me type localhost into my browser, and my browser is something that makes web requests using internet protocols. And when it did that, it was referencing my computer. It was referencing my computer as an endpoint. And so that's why I typed in localhost. I could have also typed in 127.0.0.1. Let me show you really quick why you can do that. Localhost is simply an alias in a file called sthost. Not important that you remember this piece right now, but when you're learning about DNS, which we're going to talk about actually in the cloud section, you'll see that I think this was actually a test from last time, but we have an IP address here, and this file actually allows us to map it to a domain name. So it's localhost by default. I could give this another name. I can map it to I could actually change google.com to actually refer to my computer, but it would only work from this computer, which is interesting. But do a little research on a host file, delete that, to check that out. But loopback address is that you can actually, what's in here before I start showing you random commands. What's in here? Okay, we can ping it. Let's go right next to it. So that loopback address goes through an interface on our computer, and it refers to our own system. So that's how we refer to ourselves, or the computer that we're on. Let's see. So we can ping things. So pinging, let's man ping. Ping is a great ping is a great command. It uses a protocol called ICMP to send a request to an endpoint, to an IP address, or to a domain name. And what this does is it gives information back about the response. And so you can use this to determine if an endpoint is available. So again, let's say you're troubleshooting some systems and you're not sure what's happening and you want to check if the website is still up. You're not sure if the process is running. Maybe the first thing you could do is you can ping it. Let me see here. Hold on. Okay, never mind. I thought my Synergy thing died, but you can ping it. So I can ping google.com. And it sends off and it gets this information back, and this is what you want to see. So you're sending pings to this address, and I'm getting responses. So I can see the time that it takes to get back, and this is confirming that this address is up and available. This endpoint is up and available for me. And when I get out of it, it lets me know how many packets it transmitted, how many it got back, how many we lost, and the time it took. So this is a quick way to see if an endpoint is available. So we could ping something like localhost. And if we ping localhost, we're getting information back. We could also ping, again, 127.0.0.1, which is, again, the same thing. But I can also ping things like, I'm just going to put some random things in here, .com. I don't think this is an address that actually exists. So it couldn't find this. Let's put in a random IP address. The only problem is it's probably going to do something. Okay. I'm trying to think of something. I thought that would still try to ping that. What if I try to ping 192.1? This is probably going to work. That works, because that's the gateway that's here. I was trying to show you if something did not work, what you would see. It would kind of just hang on and kind of time out and let you know that all the packets were dropped. Sorry. We're getting into, this is why I'm not teaching you networking, because now we're getting into CIDR ranges and a lot of stuff that I hate. Sets on how often 1.1.1 or 8.8 8.8.8.8 is probably pinged so many times. It's probably it's crazy. Yes, you guys are right. Networking is by and large the weakest thing that this IP works. I'm taking all of your examples. This is for Cloudflare. I wanted to see a failure, but it's all good. These all work. No big deal. But again, pinging is how you can quickly see if something's up. If my site was down, I will be able to ping it and not get a response and know that there was an issue with the service that is responding with that data. It wouldn't tell you, it would tell you that it's responding. It wouldn't tell you that, may tell you that it's responding. Very interestingly enough, if you're using things like Amazon, ICMP is not supported, is not allowed by default. Kind of got to enable it. But yeah. Yeah. Future ditch domain-based web applications. I'm sure DNS is not good for scale at all. It's not. Blockchain replacing DNS. I don't think so. This is baked deep into the core of everything. Also true, but I do think it'll have to change though. The net can work without DNS though. Yes. So the conversation people are having is, again, the way the internet works. So quick thing on DNS. DNS is a domain name service, I believe. And this is the protocol that allows you to type in, again, Google, and for it to know that Google's IP address is whatever the IP address is. So it translates a domain name like mastermind.io into the IP address that's needed for the internet to locate the server or the computer in which your information lies. It's a cool thing. It gets kind of deep. I would recommend watching a couple of videos on DNS. It sounds simple. That translation layer sounds simple, but there's a funny saying that DNS is always the problem. DNS causes all kinds of issues because it is a bit complicated. I thought it was super easy at first, but it is pretty complicated. Yeah, pretty complicated. Ping. Well, that's an internal address. Will that work? 10. It works. Cool. So it'll sit here for a while. If you can't ping something, I like that one. It's internal. And then you watch it for a while. You see you get 100% package loss. You're like, all right. Excellent. I know that I'm not getting any response from my web server, so let me check some applications. So maybe I'll check my web server first. So maybe I'll see if things like nginx are running. Maybe that's running, but not serving properly. I can check the logs there. Or if I'm not running nginx, I can check my application. Maybe I'm running an Express server or a Go server or something. I can check those things, make sure those things are running, but I can use the information that I get back from all this stuff to make decisions. It takes time to learn how to use this information to make decisions. I cannot tell you how you can use this information. I can only show you how to get the information, and time and practice will show you how to make decisions based on that information. DNS is simple, come on. No, it's not. DNS is not simple. A DNSSEC is easy. You're trolling, and I don't like it. I don't like trolls. You're trolling, and now everyone thinks it's easy when it's not, and everyone's gonna be sad when they run into DNS problems. Distribute hash table, some good code. Oh, it needs to have a good, blockchain, not blockchain. Okay, cool. So let's run through those, the rest of these things real quick. So loopback address, you know what that is. Ping, again, allows you to use ICMP to ping an endpoint or hit an endpoint, get information back about its status. And about what it's returning to you. Netstat is a great tool. You've seen me use this already. Man, Netstat. You're definitely trolling. DNS is a pain. It's not simple. It's not simple. All right, so Netstat is a networking tool to get information about network connections, routing tables, interface statistics, masquerade connections, and multicast memberships. I love to use Netstat to find out what ports things are listening on. Certain tools and services in Linux run over Linux ports. I like to say ports with a emphasized P. But you saw me use Netstat before, but I'll type in Netstat and it'll show me a bunch of information about connections to my computer, to and from my computer, which is really nice. And right now, this doesn't this information up front is really bothersome. It's really at first. There's Netstat's an interesting one that I actually didn't want to throw in here originally because there's a fair amount of networking that I think needs to be understood before you can make Netstat valuable for you. Before you can make Netstat valuable for you. So Netstat -tulpen. So you can get information about what the protocol is. We're going to talk about protocols. Just to give you a quick thing, the protocols you have are, whoa, she's running into everything, are basically TCP and UDP. They're both protocols that use to transfer data. TCP is the high level. TCP is the safer protocol. It has some tools available to you to make sure that everything arrives safely. So if I'm sending a bunch of information to you, TCP makes sure all that information gets to you, but maybe a little bit slower than UDP. UDP will it's fast. It'll just throw everything at you, but you may lose some stuff in the process. Two different protocols, use them for different things. Again, very high level. We can go way deeper than that. We will go way deeper than that once we get to the networking section. And then you get some more information about the local addresses and the addresses that are connecting, the PIDs that are either outputting data over certain ports or receiving information. The port, it shows the address here. You see like 127.0.0.1, but then you see a colon. And this is a port number, actually. So this is a Linux port number. Again, like I said, over the internet, the default port is 80. So when you hit things over the internet, default port is 80. When you hit something that's HTTPS, it has a little lock over on the side, which is really the more common thing now. That's over port 443. So if we were running a web server like nginx and we were serving data over both port 80 and port 443, we would see an entry in here for like this, and then it would see colon 80, and we would see another one for colon 443, and some other information about the IPv6 stuff. I'm telling you about NetStat so that you can learn more about NetStat. As you learn more about networking, NetStat it's a great tool and gives you a lot of information. You can use it to do some cool things about like finding how many people are connected to a server. So if you think you're getting attacked for some reason, you can use NetStat to find out a lot of information in that regards. But yeah, it's a pretty cool thing. You want a cat as service, sure. And yes, this is nice. I've sing this before. So this looks like it tells you kind of what ports things run over, services added. Oh, this is nice. So this is really nice. I'm not sure that I knew about this. This is when you would use less instead of cat. So it looks like there's a resource if you do cat Etsy service or less Etsy service. It looks like this will give you this is nice information about different port numbers and what applications, I guess, or what services are run over those port numbers. I did not know this was available. I'm writing this down. I'm adding this to my Google. I'm adding this to Keep right now, because I did not know about this. Thank you. The common ports for services. This is amazing. This is really nice. Why do they have Kazaa on here? I don't think they should have Kazaa on here. It just seems, am I dating myself? Kazaa, okay. You guys already know I'm a pirate, or I was a pirate. Well-known ports. It's a well-known port. You're right. There's a bunch of stuff on here. Wow. Okay. Nice. This is great. Okay. That's cool. So now let's do ARP. I didn't want to show you guys this either, but I thought it'd be valuable for people who are coming from I've talked to people who are trying to learn Linux from they're Cisco people, and they understand they've done networking from that fashion and haven't really dove too deep into Linux, which is interesting. But they've learned just enough Linux to kind of be able to manage through Cisco's interfaces. But you can use ARP. Let's look at that. ARP tables and ARP system caches is a networking cache, which can cause all kinds of problems. Don't mess with this right now. Just wanted to show you that it was available to you. You can cause so many problems messing with ARP in your ARP tables. You can cause all kinds of problems and not know what's going on. But again, another networking tool to add to your tool belt for sure. Again, we're actually going to talk about ARP tables. We're talking about a lot of networking stuff in the AWS portion. I didn't want to do it in the Linux portion because the goal is not to learn networking in Linux. It's to learn that there are tools available to you to get information to do certain things, and you're not going to learn them all right now, but to get comfortable, to know about enough of them to help you kind of get started and to be comfortable looking up more about tools and things that you can use, and just get comfortable with kind of the command line. And again, that's why we're hopping back into these man pages so often, just to get some familiarity and not so you're not so scared of the command line. And the last thing we're gonna do is we talked about Etsy hosts already, but I'll dive deeper into that. Remember, I just talked about DNS. I just talked about DNS, so let's do something like this. Let's do like let's dig something like google.com. Dig is a tool that does a DNS lookup. Again, we talked about DNS being the domain name service, and it looks up information. It looks up that translation between the IP address and the domain name. So I dug google.com, and it gave me back Google's IP address, the IP address for google.com, which is nice. They may not allow this. Let me see. Maybe I'll be able to paste this in and it'll work. I think there are some ways to make this not work, which is interesting. I thought it was impossible, but you can see here, my browser corrects it for me. I'm pretty sure that's a Chrome thing that'll correct it for you. Maybe all the browsers will do it now, but you can see I typed that in and it took me to google.com because that's where google.com is pointed to. What was I going to say? Etsy hosts allows you to override that information. So here's what I'm going to do. I'm actually going to install nginx again. I'm going to install nginx again, and I'm going to let it run so that we can, it's probably already running because it started up last time by default. So let's say I go to localhost. It's not running by default. Let's see. Sudo service nginx start. And look at localhost. All right, we got nginx running again. So now we have a web server running on our local computer. But let's say this host file. So the way DNS works is the first place DNS checks to see if it knows that, see if you have that translation between IP address and domain name is locally on your computer. And so we can use this host file to override that stuff. So it basically checks locally first and says, hey, do I know where this domain name goes? After that, it goes off to a couple different steps. It checks an authoritative name server and gets information. And like, basically it goes out to these servers that hold information about these translations, gets the information, and then goes and requests the IP address. This Etsy host allows us to add in sudo vim /Etsy hosts. It allows us to override a DNS, like real DNS. We can set DNS locally. So you can use this for testing, use this for a lot of things, but I can go down here. I can go down. And I can actually, let's go back up. I can actually set next to localhost, I can add another domain here, and I can go google.com and www.google.com. And now when I go to google.com in a browser, it will check my local DNS. It'll check this host file first for a mapping, and it'll say, ooh, I see google.com or www.google.com, and it's mapped to 127.0.0.1. So when I do that, it may be cached in my browser right now, but if I go to Google, Can't be reached. It's going to give me a weird protocol error thing in the beginning. I've seen this before. When there's like a weird cache thing in between. Let me open up a new private browser. Refuse to connect. Why? Hold on. Oh, this might be because of, this is actually probably because of the default setup for nginx. Let me see if I can open this up in Firefox. But you can see here, it's no longer going to google.com, but let me see. Yeah, this is actually probably due to the default settings of nginx. Oh, and it wants to do HTTPS. Yep, that is exactly why. But can I force it? I cannot force it. Well, let me show you. I bet you I can if I do it from the command line. Curl -k. Ignore that. HTTP. Actually, I don't need the K unless I do the S. Let me see if this works. Nope. That was dumb. That was stupid. And I don't need the. Whoa. I don't need the K. Let me just first. Let's just do that. All right, so if I do it from the command line where I don't need HTTPS, so my browser is trying to push me into a new protocol, and the web server that I just quickly spun up is not actually serving over that protocol. It's not serving over 443. It's not secure. But if I do it from the command line, you can see here I get a welcome to nginx, and welcome to nginx. If you see this page, the nginx web server is successfully installed. That's what is displayed from our browser. Yeah, and my browser just won't allow me to make this request because it's not secure. It's keeping me safe. But you can see I went to Google. I didn't go to localhost. I went to google.com, and it ended up going to my nginx stuff rather than real Google. And if I edit again, and I remove those things, and now I do a curl. It's gonna give me a redirect to HTTPS. And when I do it, it's gonna give me another redirect to www. Oh, it's the same redirect as before. And now this is what you really get from Google, which is all of Google's information. This is the internet request output from what you're typing in the browser without your browser interpreting it. Super dumb when you do it here. It doesn't make any sense. But curl is a pretty powerful tool as well. But that's what ethost does. It allows you to override your DNS. And this allows you to, you can use this for troubleshooting. You can use this to figure out network issues and things like that as well. All right. Yeah, I should have just done the Python HTTP server. I should have done that. Told you nginx bricks a lot. It didn't brick. It didn't brick. It didn't brick. It does not. I don't have any certs set up, man. I'm not using Let's Encrypt. Do it incognito, forces a new DNS lookup. That. Do you have the HTTPS everywhere plugin? I do not. This is default. Browser is like, nah. Yeah, the new browsers, I do like that because people aren't smart, and I do think they need some of those protections by default on the internet. Yes, actually, let's scroll up a little bit. When I did google.com, we see this 301 moved. This was Google trying to redirect me, so you can do some cool networking things with DNS or with response codes. And you can respond and let people know where you try to go to google.com, but what I really need you to do is go to www.google.com. And so that's what they're trying to do here, but I didn't tell my curl command to follow the redirect. That's why it only gave me this. Same thing here. Let's see. Are we going to go over nsswitch.conf? No, not yes, but not now. This is like a super intro to just like the Linux tools you have available to you right now. We will definitely get into that when we get into most of the, like, all this stuff is going to come into play when we get into the cloud portion, when we're actually on a server. Now it's not cloud specific. It's still going to be Linux specific, but we're going to be doing this stuff from a server where it matters a little bit more than trying to do it locally. More secure than Google, it would have worked. Not necessarily. No. Actually, if I picked any site that only serves over HTTPS, it wouldn't have worked. And it tries to redirect me, it would not have worked, I don't think. Only reason it didn't work is with 301. I don't think that's why. Well, it is why. It is why, and I think most major sites are like that now. It resolved properly, but the browser was trying to get me. Was trying to ensure that the browser knows Google it is a secure site. Like it knows that, and it's trying to force that. I'm sure in somewhere here I can disable that. But I don't think that was because of the 301. Because the 301 wasn't just to HTTPS, it was to also www. Your computer looks up names to get IPs, then connects you to them. Yes. Yeah, see, I was gonna say most sites probably do that 301 on HTTP. Yeah, HTTP is, I mean, you should, I wouldn't say hate HTTP, but like there's no real reason anymore to not use HTTPS. It used to be a hassle. You used to have to pay a bunch of money for and what's called an SSL certificate, which is really a dumb name because SSL is actually deprecated. It's actually a TLS certificate, to be 100% honest with you now. But no one calls it that. It's called SSL certificate. But a certificate that secures your site. It encrypts the connection between your site and the user. And it used to be costly to do so. Like, it used to be really costly to do so. It is free now. There are many options for it to be free or really, really close to free. So there's no reason for your site not to be secure anymore. All the cloud providers will basically give you, well, maybe not all of them. Amazon will give you one for free. I actually think Microsoft does not have a certificate manager. I think you have to purchase certificates from them. Yes, but there are tools like Let's Encrypt that will, yeah, you just said it. We'll do it for free, which is great. But if you're using Amazon, you don't even need to use Let's Encrypt. You can, but you don't even need to. They have their own Amazon certificate manager. They'll give you a free cert, which is really nice. Yeah, we talked about Dig a little bit. If you're trying to figure out what, if you're trying to know if you're trying to look up the DNS information or the translations for a certain website, like if we were trying to do Dig Mastermind.io, I actually have that's interesting. I actually thought that was only going to give you a CNAME. That's very interesting. What happens if I do Dig? Sorry, I'm interested in this. CNAME Mastermind.io. What? It doesn't do subdomains, does it? Oh yeah, it does. Okay, got it. Mastermind.io okay, I got it. I'm tripping. An Academy should give me a different CNAME. The same? That's different. Okay, never mind. Yeah, but you can look up the address. You can see that this is actually just another domain. Yeah, you can't do it. You can't do CNAME on an Apex record. Yeah. That's, yes, 100%. So interestingly enough, that was like one of the big problems we had to solve when I first started my project is not being able to do CNAME on the Apex record. We had a lot of issues with our Apex records actually when we first started, which is very interesting. I understand why you can't use a CNAME on an Apex record, but I wish you could. It's very annoying. It's very annoying because I still think the www subdomain, I still think it's stupid. I think it's dumb, and I don't like that we're kind of forced into this paradigm of www dot, but that's fine. I understand technically why C names aren't allowed on the Apex domain, for sure. All right, that is that's the end of Linux management part 2. So we learned a little bit about installing packages. That's what you're gonna be doing a lot of the time, and removing packages and using package managers. Learned about it. We learned how to install from source, so that configure, make, install. We learned about process management, so you can see what's running. So mess around. I want you to mess around with these things. I want you to play with PS and like look through there and see what's in there and see what keys you can hit to give you information in a different format. See what you can do with it. Check out top and htop, very important. You'll learn about how you can see your memory and your disk space, as well as some basic networking commands. Ping probably being the premier one, and knowing what your loopback address is, what a loopback address is. Actually, I'm gonna throw one more at you, which I think is very important. One, this is how you get your IP address, and this is like I'm just going to change internets so you guys can't mess with me. But a way for you to see your information about your network cards and your connection. So if you want to see what your IP address was, I could go to Google and type in what is my IP if I wanted to. But if you're on a server, you can't do that. But ifconfig gives you information about your network cards. So it gives you information about your loopback address. As you see here, loopback running. My IP address is 127.0.0.1. Everyone's computer will have this, and it will be prefixed with this LO for loopback. Oh yeah. So, yep. ifconfig is very crucial. And so it will also show you what your network card, the network cards that you have attached. It'll show you what they are. It'll show you what they are. And so I can see here what my IP address is. So this will match. This is my IP address here. If you want to try to do something to me right now, you can try, but I'll just restart my computer and connect to a different. I can connect to a bunch of different networks here. I'm not sweating it. I'm not afraid of the internet. But I can copy this. This will be the same thing as if I type in into Google. What is my IP? Or it should be. I've seen it be different before. Which it is, because this is my public IP. Sorry, this is my private IP. This is my private IP right here. For this network card, I should have known that from the 192. Wasn't really paying attention. But it gives me information about so this WLP59SO is my network, is my wireless network card, and the connections that are associated with it. It gives me some internal addresses for that. It gives me some information about gateways and broadcasts and net masks. Again, these are all things you'll have to pick up. These are things you'll have to pick up as we get into the networking portions of this. Yeah, I know it's private. I know. That's how I know it's late. 192.168. Again, if you've ever had to set up your own home network, they probably told you to go to 192.168.1.1 or .2.1 to be able to log into your router and set things up. There are IP addresses that are reserved for internal use, things like 10 dot whatever and 192, and I think 172 I believe is another one that you would use, but they're reserved for local networks and local machines for networking in that space, so that basically they're reserved so that you don't run out of IP addresses for local connections, because local connections are very important. And it was one of them. I saw that immediately. And then I probably have, right here, we've got an IPv6 address. So remember I told you about IPv6. And I wonder if this is my, what is my IPv6 address? Or even if we can get IPv6 here, I don't even know. Not detected. So I guess the internet that's in here won't give me an IPv6 address. No, I have no idea what the internet that's running in here is. But what is if this is not this is what is this? This is the MAC address? It's probably the MAC address for this. Oh yeah, it's probably this is okay. Yeah, it's probably the MAC address. Ether, pretty sure. Oh, okay, it looks like you said it here. Yeah, MAC address. Yeah, I this is interesting. I actually want to connect an Ethernet here. I've actually never seen what this is. This is interesting. This is very interesting. Maybe it's because of the laptops that I've used before for Linux. But I usually don't see my wireless LAN and my wireless card. And oh, you know what it is? I've never had a laptop in recent years with an Ethernet port. Interesting. Okay. All right. It was confusing. Yeah, you think use Mac? Yeah. Yes. I promise you, I know these things, but sometimes I get tired. I'm pretty tired right now. But cool. Let's see. Apparently, use MAC address as the fight auth method. Apparently they used someone else's Mac, so I swapped. That's interesting. And elite status. That's awesome. Oh, that's really cool. So on a flight. I like that. Oh, at a hotel. I swapped my Mac the other day at a hotel. Yes, and that is why spoofing MAC addresses is elite hacksaw status. It's not really, but it's a simple way to do exactly what you just did, Thug Muffin. That's pretty cool. What was after configure a tar file? It was a make command. Man, see, this is why I don't connect to the internet at airports, because people like you guys are out here spoofing and confusing me, and I don't like this. I don't want nobody airdropping me anything. I don't want none of it. I heard of people charging drinks and such to someone else's room. Yes, I have seen people charge to other people's rooms with Mac spoofing. It's definitely a thing. I do think that a lot of hotel Wi-Fi's have gotten better to make it a bit harder. But yes. 2 hamburgers in one sitting. I almost ate 3 hamburgers today in one sitting because I ordered 5 Guys, which I shouldn't have ordered, but I've been working out really hard and I was tired and I deserved it. Terrible attitude to have. But I thought an extra patty was going to give me 2 patties, but I forgot how 5 Guys worked and it gave me 3 patties. But luckily the pup's here, so she got herself a nice patty, a nice 5 Guys patty. All right. Y'all are the reason why people hide information. Yes. Yes. Well, it's funny because it's not even the people that are in this chat. There are way more malicious people out there than the people who are just spoofing for fun. For sure. There's people out here doing real things. But yes, we definitely contribute to the problem. I don't contribute to the problem. Pen testers. Yep. We're just making sure that the world is safe. We're testing networks. We're not actually trying to cause any problems. All right. So what time is it? 11:11. I think we're good for tonight. So we'll get hands on with some Linux next time. We're gonna do some bash scripting. So we're gonna combine what we learned in Go, kind of the concepts that we learned in Go, and we're going to learn how to do things on the system in an automated fashion. We're going to learn how to use bash. We're going to learn about what bash is and how to use it a little better to actively be able to make our system again more automated, better, do things automatically, which will really be nice. It'll be if you if you paid attention to the Go portion, it should be pretty easy. We're going to be doing a lot of the same things. There are variables in Bash, there are loops, there are if statements, there are conditionals and things like that. We'll be using all those things to make some dope things happen. Now that we've learned some Bash commands, it helps that you've learned how to navigate. It helps that you learn file paths and things like that, so that we can put those things together. Yeah, I think you'll be fine. Even if you miss Go, I think you'll be fine. Just maybe some of the concepts, maybe when we get to like writing a loop or something, you may not get that immediately, but no biggie. We'll explain it and we'll try to get through that. You can ask as many questions as you want about that. Let's see. Let's go to, what do we learn after that? What are we learning after that? After that, we're going to do lab day, and then that's where we're going to networking, and that's where we're going to learn all the bigger stuff that we learn in ISO, the protocols and what DNS is, and we might not even do FTP. Well, we'll talk about it. But in here is when we're going to learn a lot more about all the things that we kind of hopped into. We'll learn a little bit about ARP tables. We'll learn how to use netstat a little better and have it make a little more sense once you get a lot of this stuff. Once you get some of the concepts that are going to add to that, so that'll be fun. And while this is not a Linux portion, this will be still everything from now on out will be heavily Linux related. We'll be using we'll be throwing commands around. You'll be learning Linux throughout this whole thing. So don't sweat that we've only had 2 dedicated Linux portions. Everything we do from here on out will basically be Linux learning as well. So we're doing a lot of stuff with that. I wonder if a Discord would be good for these classes. There is a Discord if you are subscribed. There you go. If you're subscribed, you can get into the Discord. There's also a Slack. Let's see. Cars use VPN in Ubuntu updates. They use OpenVPN. I like OpenVPN. If you have to do a VPN, OpenVPN's fine. It's pretty easy to set up. It's kind of nice. All right. That is the end for tonight. What is tomorrow? Tomorrow, do we stream tomorrow? Tomorrow is Coding with Python. If you're learning the Python stuff, we have last night we learned about data structures, and now we are getting to operators and expressions. So we did this stuff in the Go class, but yeah, now we're going to get into comparison operators, and we're going to start adding some logic into our code and making some decisions in our code. So that's going to be exciting to do tomorrow in Python. That'll be it for the week. So if you want to learn any Python, that is tomorrow. Cool. Or TeamSpeak. I've used TeamSpeak before. TeamSpeak's fine. We could do some TeamSpeak stuff. Actually, we might use some TeamSpeak for. I really want to do some like mob programming sessions and like mob. When we get to like infrastructure as code stuff, I would love for some people to kind of, even though I'm a Vim guy, maybe we could use a VS Code and do some live share, and kind of all hop into the same browser and maybe do our best to kind of mess around together. Maybe use a TeamSpeak to communicate. That might be kind of cool. Yeah. All right. Is Python essential for Linux portions? No. It's not at all. It's not at all essential for Linux portions. And the Python course is really not a Python course. It's an introduction to programming course, just using Python, because Python is a solid language to learn coding concepts in. Yes. I think you'll be able to apply all the things that are in the Python course to other programming languages. Yeah, it's definitely a crash course. What was I gonna say? I was just gonna say something, but I forgot. Let's see. We always raid somebody. Maybe we'll raid somebody different tonight besides the Primigan. Hey, Still Digital. I think I got that. I'm getting better at seeing these names and reading them. Thank you for the follow. Welcome. We always go over the Primigan. Maybe we'll give someone different a shot tonight. Let's see. Categories. Science and tech. Who's on here? Who's gonna allow? Oh, but the Primigan's doing Vim Royale. He's building his Vim game, which is pretty cool. But maybe we can head over to let's see what looks good here. Astronomy nerdy. All right, that's cool. Raid. I'm still in that right now. You guys give me somebody. If it's only gonna let me raid him if he's like family friendly, which is I don't know. We'll see what happens. All right, we're good for tonight. Another week down. I'm going to release all the stuff in the Google Classroom. I'm going to update it from being this morning, so you should see that stuff shortly. Also, before I leave here, I'm copying all the videos that I have to upload to YouTube. I'll get the names on them, so you should be able to see the videos in the morning. They may not have names on; they'll have the titles, but they may not have a lot of information. But yeah, so you can expect those things. A Cloud Guru before? Absolutely. I use A Cloud Guru to study. I use it to get my cloud certifications. It is an excellent site. It is a great resource for both learning the content for the exams as well as keeping up with all the changes in like cloud, like all the cloud changes, which is a little bit interesting. It can be overwhelming to kind of keep up with on your own, but yes, A Cloud Guru is really good, and I highly recommend them. All right, we're heading over to Econ Greg, and we're going there in 8, 7. Oh wait, it froze. Oh no, 4, 3, 2, 1. Let's go over and say hi to Greg. Everybody have a good night. I'll see you next week if you're not coming to Python.